Hello everyone, welcome back to Ask a Scientist Gaming, where we combine mediocre gameplay with expert science. I'm Ken Hansen, Associate Professor in the Department of Chemistry and Biochemistry at Florida State University. I'm a photochemist, which means I use light to drive chemical processes, whether it be bond breaking, bond making, or using those photons to generate electrical current as you do in solar cells, or doing catalysis with those photon energies. But more importantly, joining me today is Dr. Lance Cooley. Lance, if you wouldn't mind introducing yourself.
Yeah, hi. I am Professor Lance Cooley, Dr. Lance Cooley. I'm the director of the Applied Superconductivity Center, which is part of the National High Magnetic Field Laboratory. I'm also a professor of mechanical engineering. I've been a scientist for almost 35 years. So I'm not a young pup.
So do you teach classes as well?
Yeah, I teach sophomore and material science. Right now I'm teaching a senior level class on applied superconductivity. But I am part of the teaching faculty in the College of Engineering.
Oh, makes sense. All right, equally important, what game are we starting with?
All right, so we're playing Overwatch. We're going to play Overwatch 2 for most of the night, I hope, until our hands get sore on the controllers here. I don't have any of the hand warmers to warm them up and loosen them up, but...
Unlike most of our guests, Lance actually plays this game. So he's a regular and is joined by his daughter. I don't know how much
that's right. You got the headphones here. That's my daughter in my ear. She's my wingman, wing girl, and she's my backup healing on a lot of what we're doing here. So, and she's also driving which matches we get in. So I don't know if we're going to be on casual or intense or competitive or where we're going. So
Olivia, we should do exclusively rated games. We'll see how far we can tank Lance's ranking in this 3-hour interval.
Oh, we're going to have a lot of fun. Yeah, I mean, we're probably queuing up somewhere. I don't know where, because Olivia is in control.
Wow.
Oh, total mayhem. Oh my gosh.
So how long does it take you to queue up for a game in this?
It depends. It can be almost instant, and then sometimes you can wait 10 minutes. I think the server's pretty fast tonight and hooking games up, so this will be a lot of fun.
I see.
Yeah.
And it lets you pick connection speed versus local versus... Does it give you that option of prioritizing who you join with?
I think it tries to. Whether it succeeds or not is another thing. But... oh boy, total mayhem. What do I want to do
for those
here?
people that haven't played Overwatch 2, Lance, this is 5v5?
Yeah, it used to be 6v6, now it's 5v5. It's an organized team, a balanced team. You see Wednesday up ahead, that's a tank. Lots of hit points, lots of armor, lots of power, but also a great big target. Then you got a large class of what it called DPS, damage, more or less, right? There's our tank, and then I'm playing a support role, where my role is to keep everybody healed, try and help keep the team from dying if I can, and pick off a few pot shots from time to time when I'm able.
Oh, that's nice. You can do damage as a healer.
Yeah, well, some of the supports are much more powerful in in their ability to heal, and less powerful in their ability to attack, and vice versa, right? So.
Yeah, I appreciate this game because they combined aspects of the first-person shooter plus like the RPG World of Warcraft strategy. Right. That's fun.
They're really good teams. They're in constant communication with each other on their headsets. They have quite a high level of communication and protocols for calling out different shots. Often if one person leaves the bunch, it's like a death ball rolling in and chewing that single person up, and then proceeding to use the advantage of numbers to continue to mow down the rest of the team. So, I
mean, is this one of those that no one wants to be a healer kind of thing if you're randomly paired?
Sometimes no one wants to be a tank. Sometimes no one wants to be a healer.
Yeah. DPS is the most fun, right?
Yeah, and here now we got 3 healers, so I got to change. And
it's a good problem to have.
Yeah, and so I'm going to move over to... Where do I want to move over to?
Of course. They are delightfully.
I'm going to move over here.
And these different characters have different
different weapon loadouts, that's right. Different damage capabilities, different survivability.
Speed versus endurance.
Yeah, and I got to remember what my buttons do now, so this could be a train wreck, but... Oh yeah, that one throws a dynamite. Okay, good. And that one, that's the one I use to blast people away. All right.
Oh man, is there team harm on this? Can you do damage to your teammates?
No, there's no friendly fire.
Okay.
Thankfully.
Like dynamite stick down a hallway. Not the greatest, but no friendly fire. We are okay, ladies and gentlemen. And this is, you're going to a score?
Yeah, this version, we're trying to escort that payload there to a finish line.
I see.
And the other team is trying to prevent us from doing that. But in total, I got resurrected. Look at that. But in Total Mayhem version, you get quite a bit more damage points, an ability to blow stuff up, and an ability to reload, and other things.
That's fun. So it has objectives, but also there's free-for-all killing, and
Yeah, Mayhem and all that, yeah.
that's fun.
Get this guy, get this guy, get this guy.
All right, so you have controls figured out. You're content?
Yeah, I think so.
All right. Well, we'll start with an easy one before we go into the science. So, obviously, 5-year-old Lance didn't say, I want to be playing video games talking science at some point in his career. What was the path that got you from there to here? What were the major milestones? He said, I'm going to be a scientist. I'm going to go into mechanical engineering, in particular, superconductor materials.
Yeah, so Lance is actually a physicist. Engineer, I'm really a material scientist, which is a combination of engineering, physics, a little bit of chemistry, but young Lance was kind of the type of kid that the school system doesn't know what to do with, where, I graduated high school in 3 years. I stuck around for sports because I was a student athlete. I ran the mile and had a track career in college and all of that. But, I was always interested, I was always bored because the, regular school just wasn't enough. And so, fortunately my parents set me up with amazing opportunities. I grew up in a small town of 3,000 people in Wisconsin, a high school of 800. So you can imagine the number of things that are available. Oh, I got plowed. Oh, I escaped. Look at that. We took lots of trips to Chicago, to Museum of Science and Industry. We did lots of activities where you could just kind of brush up against interest, curiosity, wonder, okay? And that would be my first bit of advice. Don't lose curiosity and wonder. That's the prime ingredient. And I always kind of had that. Coming out of high school, in my family, we always had a lot of pilots, and we were always flying. I loved flying. My big decision in high school was actually I had an appointment to the Air Force Academy, and I was going to go fly jets, right? And I'd actually gone out, got my combat boots, did the bayonet assault course, had a briefing with the commandant of cadets, who said more or less, son, we're here to make you a career officer. And that was maybe a scratch the record moment where, I want to fly that thing through that cloud at Mach 8 and do all this aerobatic pilot stuff. And okay, well, maybe I didn't make the right choice. And a little while later, I was always really into physics and hard science all the way through high school. So I actually had the opportunity to go to the University of Chicago and listen to Jim Cronin give a public lecture just after he had won his Nobel Prize. And it was a wonderful lecture because he talked about the asymmetry between matter and antimatter in the universe, and why antimatter's gone and matter is here, and what particle interactions kind of gave everybody evidence. And oh, by the way, if you take physics as a major, you will have me as your junior course teacher. And I'm like, oh, okay, I'm there. And sort of at that same time, I suddenly realized that University of Chicago was one of the big universities that played a major role in the Manhattan Project. The first atomic pile, there's a monument by the library where the first sustained controlled nuclear reaction was underneath the football field. And all of the notes from the ghosts of the Manhattan Project were kind of around the halls. and on the walls and that kind of thing. So it really was the right place to be. So I got a Bachelor of Arts in physics. I have a music minor to go with my Bachelor of Arts major, or my physics major. But, that you can kind of get right away from there. I've had a broad range of interests. I've always been, chasing wonderful things, but also given the opportunity to, climb into some of the biggest, most complex things and dance around with it. Oh boy, defeat. And,
Close. Am I blocking the score?
No. And really just find my limits. And I would say I didn't really find my limits until sort of the time I got towards graduate school. I still haven't found my limits. I'm still curious about all sorts of things. But, when you get to a point where, okay, I kind of know what I want to do, and I kind of know what I'm capable of doing, and let's put the two together now and chase a path, right? And, about that time I did my senior project with Jim Cronin's group. Actually, he had a project at Fermilab, and, hold on a second here, we'll click one of those, all right? And we started working on, it was something mundane, measuring the time for electrical signals to go from one end of a cable to the other end of the cable, because they had to be timed down to nanosecond type levels, and the length of the cable and the conductance and whatever of that cable matters, right? Jim had something going on at CERN, so he left, and I re-engaged with a project in superconductivity as a senior, and that's sort of where I really brushed up against that. I got into graduate school at the University of Wisconsin, and on my journey there, I got a nice letter from the I got into the physics program, but I got a letter from the head of the material science program and said, come to material science. We will pay for you to go to graduate school. You can have your choice of the different professors, and we'll give you a little stipend besides paying for your tuition. It's like, wow, okay, I'm there. I'll do it. Just sign me up. Here we go. One day I was walking down the hallway of one of the engineering buildings, and somebody says, hey, Lance, what are you doing here? And, hey, Martin, what are you doing here? And somebody from my class, co-graduate from Chicago. Who knew? Small world, right? Who was in Professor David Larbalestier's group, the Applied Superconductivity Center, which I'm now director of. This was in 1986. I'm kind of just wandering around, bumping between opportunities, and I locked on. Right?
Yeah.
So, I don't know, there's a few lessons in there. Bump up against opportunities, set yourself up to be able to take advantage of different opportunities when they come. Be open-minded. Have around you people that you can trust and count on for opinions that you can help you maximize your opportunity. All those different things were kind of around me.
Yeah.
And have fun with it. Grad school is the best time of my life.
Be passionate about what you're doing.
Yep, be passionate.
Makes it easy.
I tell the tours, I get to play in a sandbox every day. It's the most wonderful thing, right? Because it's something that I've always wanted to do or wanted to be curious about and have been curious about. And, that's what keeps the day-to-day activity, even now, just so much that I can't wait to go back. I lose sleep because I missed some things. I was counting on a couple things turning out. They didn't turn out, and so the plans keep rolling, right?
Yeah.
And yeah.
Well, it's pros and cons with that lens too, because you don't get to leave it at work.
Yeah, right. Exactly.
Sometimes
exactly.
That's awesome.
And those 2 a.m. moments come fairly often.
Yeah.
Right.
Good or bad, they come.
Yeah, exactly. And then, in the later stage of my career now, I'm responsible for so many people. There's 52 people in the Superconductivity Center, and you take a lot of that baggage home with you. So there, I'm fortunate also to have had training in management from my time at Fermilab. And so for me, I understand these burdens, and I've spent parts of 6 years being coached and trained in how to deal with these burdens. But
Yeah, that is one undertraining we have. Most academics is not enough management training.
Yeah.
Because we go directly from a postdoc to academia, and yeah, we don't know what we're doing, and we make it up as we go.
Well, and humans are the biggest part of science.
Yep.
It's a human interaction. It's not a technical interaction.
Humans are hard.
Yeah, that's right. Humans are hard, right? I mean, you can be the smartest person around, but if you can't explain what's valuable about what you're thinking,
Yeah.
to somebody else, who's going to care? So what? Big deal,
Yeah.
right? And especially those who, are responsible for the public funding, right? Why should we waste the taxpayer's dollar on this if you can't tell me what it's good for, right? And I've always been frustrated by things that are completely abstract, especially when the person working on it can't explain where's this going, what's valuable about it. But at the same time, basic science is full of stories like, we didn't know why we're studying these jellyfish, but it turns out that the dye in the jellyfish gives us a way to label certain proteins that are important to understand their function in medicine.
Yeah.
Right, I forget what commercial it is. This was discovered from a protein in jellyfish.
Yeah.
Right.
No, I do feel that frustration sometimes, though, especially the quantum information science
Yep.
bubble right now.
Yep.
I mean, there's some people that do truly get it and understand it, but I get the impression that a lot of people are just riding that wave without actually
Yeah,
understanding.
you're part of the workshop this past weekend?
No, I didn't actually go. I should have, but
Yeah. I mean, we worked a little bit on quantum when I was at Fermilab a decade ago, because some versions of quantum bits can be superconducting, and they want to have a quiet environment in which to quantumitate, right, for lack of a word. And, so at that time we were working on radio frequency cavities, which are an important part of an accelerator. But the cavity also creates a very protective environment around electrical systems like that. So, and I had the opportunity to talk with some of my old colleagues, and his opinion of the quantum information activity was that everybody rushed out, formed big teams to get the available big funds, but it's now a confederation at best of a lot of ideas that aren't really combined together into coherent strategies, and
yeah.
right. So,
I mean, it's progressing in that direction, but there's...
And that happens that way
Wild West.
sometimes.
Yeah.
Get me out of here. Yeah. All right. I was slow on the draw there. The nuclear bomb blew up right in front of my face.
No worries. I mean, so FSU just officially got their Quantum Science Institute approved.
Yeah, the Dirac Institute for Quantum Science.
Yeah.
And that's good,
Yeah.
because we do have a lot of creative ideas that aren't really expressed in other places.
Well, and with the Mag Lab, we have the tools to pursue a lot of that, too.
Yeah.
Which is exciting. I mean, I'll be making molecules for someone at some point.
That's right.
It unfolds.
And whether those molecules are, require high fields, low fields, high temperatures, low temperatures, but artificial atom systems.
Oof. He's shooting.
I got toasted there.
That's part of the game. You can acknowledge the good play of your opponents. You're more mature than 99% of online gameplay.
Yeah. I gotta stay here with the team. There we go, Diva.
Do you ever do like open mic with teammates? I mean, how
sometimes. Usually just me and Olivia, are on each other's mic.
Yeah.
Partly because, there's a range of personalities, and I don't care for the, the sniping and that sometimes comes along with the gameplay.
Yeah.
And I'm just here for the fun, So if I didn't heal you, too bad. I'm sorry.
No, people take it seriously.
Yeah, that's
sure.
right. Didn't you see me there? You should have healed me up. And,
Exactly.
Yeah, well, okay. I'm just an evening gamer. Too bad that I got connected with you.
Exactly.
Yeah, I don't control the queue.
All right, anyone just joining us, our guest today is Dr. Lance Cooley. He's an expert in the engineering and application of superconducting materials. So if you guys have any questions, I mean, this ranges everything from big magnets to particle accelerators to handheld electronics.
That's one of my other day jobs is I've been buying all the conductor for the upgrade of CERN. So
that's interesting.
Yeah, so the Large Hadron Collider, right? There's two main parts to the ring. I always say there's 5 main parts to an accelerator, but in the ring you have quadrupole magnets that focus the beam and dipole magnets that bend the beam around the circle and contain it. And the most of the magnets are the bending magnets, right? So they keep the protons flying around the ring and so on. But at some point, you want to take the beam and squish it to a tiny spot. Bring the cloud down to a point and focus that point to make intense interactions happen. So there's a set of magnets that are the quadrupoles, which are kind of like the lenses of the microscope that do that squishing and focusing. And since they're right next to where all the physics is happening, they get full of radiation. They eventually, degrade.
Yeah.
And we knew back in 2003, when the construction of LHC really got going in earnest, that this was going to happen. So an upgrade was already planned. Now, they didn't turn the LHC on until 2007. Right, but the upgrade was already underway in the form of a decade-long research program to grow the technology to get those better lenses when the main quadrupoles that were installed in the first place burned out. Well, now we're at that point. The machine is shut down. The Large Hadron Collider is shut down, and we are nearly done with the manufacturing of the upgrade quadrupoles. Which will make physics happen about 10 times faster.
Well, so you guys are making those at the Mag Lab?
The United States, Berkeley Lab and Fermi Lab and Brookhaven Lab are building the magnets.
I see.
Mag Lab is characterizing the conductor going into it. So I've been procuring 30 tons of conductor and verifying its quality and all of that.
Who do you buy that from?
The company in New Jersey, Brooker OST, makes that conductor.
Brooker does. Okay.
Yep. And but they're very stringent specifications. It's some of the highest performing superconductor that's ever existed, right? And and this is the type of project. It's the first time we're putting niobium tin magnets in an accelerator, and so it's a type of project that cannot fail, right? Because this is a new technology, or it's a technology transform to the next generation, and we have to demonstrate this for the future accelerators that we might contemplate and build. But that production run has been going on since 2017. I mentioned the research program started in 2003, ran through about 2013, and then there was a middle portion where we had a pre-production run and actually bought quite a couple tons of conductor just to verify in quantity, or production in quantity, that things work. Right. Oh, I'm going to escape that one. No nuclear bomb in my face today.
Nice. Congratulations. Do a GG on that one. All right. The other important question: what are we drinking today?
Yeah. So, I love whiskey. I'm part of the Tallahassee Whiskey Society, and this is a whiskey experiment. So this is a $20 bottle of whiskey, benchmark foolproof, that you can get anywhere. That is about 4 years old, and we took it and brought it back into a cask, but a tiny cask where the surface area is very high. So there's going to be a lot of interaction with the oak, and it's been in that cask for a few months, and we're starting to taste the benefits of a little additional oak, a little more smoothness. Cherry notes are starting to come out. Some caramel toffee notes are starting to come out. The original juice is pretty good. It tends to be a little hotter, cinnamony, spicier. Anyway, that's the way I think it tastes. But it's calming down. But Shh, it's 130 proof.
So you just sample out of the barrel every once in a while until
Yeah,
you're ready,
yeah.
and you're just like, here's
That's
the sweet
right.
spot.
Yeah, and it could be, in a Florida environment with a lot of heat, the aging could go really fast. And so what I might need to do is, we're going to go 2 tank. Yeah, come on. What I might need to do is call it and get it all into bottles real quickly, just to make sure that I don't overage it. Because you can get some other less desirable notes if you get too much.
Yeah, I was going to say, what's the consequence of overaging?
Yeah.
What is that?
Yeah, you're going to end up with some, I want to say nutty, pecan-y, charred kind of notes and like that. One of our friends in the Whiskey Society says, well, I don't care. I'm a termite. I like lots of wood. I like over-oaked whiskey. And I do too. I like a wide range of whiskeys, but very oaky whiskeys, they don't turn me off.
Ethan Lambert, my dad's, my friend's dad used to age moonshine in oak barrels.
Yeah, there you go.
Turned it in the smoothest whiskey I've ever had.
Yep, straight corn moonshine, or did he mix some rye?
Oh, that's a good question, Ethan. What kind of whiskey?
Yeah. I mean, if it's bourbon, it's 51% corn.
So what goes on at the Whiskey Society of Tallahassee? What it's regular meetings and just tasting, or how does that work?
It's more of an online community with a lot of discussion and buying bottles that are finds that people can't get here or can't get there, and then either sharing the notes of the bottle or maybe exchanging bottles. There's a secondary market, but also getting together for bottle shares, bottle tastes, comparing different flavor profiles and favorites. So we have a big group that loves Wild Turkey and John Rutledge. We have a group that likes Jim Beam, Nog Creek, kind of nutty Heaven Hill products. We have a group that is a fan of the Old Forester, Brown Forman. It's not Brown Forman anymore, but those lines. Four Roses. There's large, just like wine and Napa. There's large houses of whiskey, but moreover, different rick houses, different terroir, land that the whiskey comes from.
Yeah.
Different aging years, aging cycles affect the taste of the whiskey, and you can actually pick that up, especially if you've got a guide, who's been
Walks you through
in
it.
it. Yeah. You get a guru that, okay, now try this. Now try this. Okay, can you find the differences between the two? And all that.
Ethan answered, it was straight corn. Mash came straight from Tennessee. That's awesome.
Tennessee corn whiskey. Yeah, love that.
I mean, so is there, I know there's a lot of wine tastings, but is there like a bourbon whiskey scotch tasting in Tallahassee that you've gone to?
I've gone to several with the friends in the society.
Yeah.
Right. I've not gone to many where it's, we have a couple very excellent establishments here that have whiskey menus.
Yeah.
Right. And I've not gone there and enjoyed some of the whiskeys they have on their menu.
You want to plug them on stream? We're not sponsored, but we're happy to share knowledge.
I mean, well, let's see. I'd have to think 850 and what's up on Bannerman.
Ology is another one. They've started.
Yeah, Ology is now making whiskey.
Yeah.
That's right.
Yep. I haven't had theirs, but apparently, yeah.
Oh,
like
they have a new release that is out. I think you can get it at Market Liquor somewhere in town.
Oh,
it's
nice.
Total Wine. I think it's a store pick. But yeah, our Whiskey Society gurus picked out magic barrels, that have been blended in the Ology product. And,
nice.
And hopefully one of these years it'll be all Ology, all their own juice. They're not yet at a point where they can make enough and build enough inventory to be called solely Ology.
I see.
What happens in the whiskey community is that you get a lot of I gotta get out of here. Run away. All right, there we go. When you start up, you get a lot of companies that source their whiskey from a big producer like Four Roses or something like that, and you have a hug. Sweet dreams. That's lovely.
Yeah.
That's a while ago for me, but
Yeah. She's just starting to game a little bit, so
Yeah,
it's kind of
oh boy.
fun. We're doing a little bit of Lego Star Wars. So pretty
my team.
friendly. Lorianne said Deep.
yeah, Deep is a beer brewer, and I think they're starting to make spirits as well.
Yeah.
I mean, I've been a home brewer for 25 years, and I know some of the people at both Ology and Deep and Lake Tribe and around. I'm part of the North Florida Brewers League.
Oh, nice.
But now that my metabolism slows down, I got to watch out for those beer calories.
Man, I'm glad a lot of those survived through COVID. I mean, just
yeah,
a lot of
it's just good
restaurants
times,
Yeah.
right? Good times, good beer, just hang out. North Florida Brewers League recently just had their spring group brew, and I'm curious to see what comes out of that.
If you don't mind, I'll steal more. You want more?
Most definitely.
Do you have to teach tomorrow morning?
I don't have to teach tomorrow. I'm going to teach at 12:30 tomorrow.
No. Yeah, that's not bad.
Yeah.
That's fine. Make the most of it.
Uh-oh. It's a battle of ultimates. Get her, get her, get her, get her,
All
get her,
right.
get her, get her, get her, got her. Ha ha! Yeah, but I let my team die though. Oh no.
So, brewing hobbies aside, what was your I made it as a scientist moment? Like, what was your
There've been several.
yeah? We'll start with the first one.
I think the first one was the first conference that I went to, and I had a discussion with another senior scientist, and out of the kindness of his heart, maybe, I don't know, but I was recognized as a peer. And that moment when you're hobnobbing with the other wizards, but they call you out as a peer and want somebody else to listen to what you say, that's the moment, that's a very special I've arrived.
This was like in a social circle, or this was like a Q&A session?
This was a workshop.
Yeah.
Right? And, like we
Another
do
victory. Well done.
Hey, yeah, good team. But like we do with our graduate students, we heavily promote our graduate students. They're working hard. They're doing brilliant stuff. And certainly I was being promoted, and I was being, given a stage and the freedom to talk on the stage. But then when the person you're talking to tells his colleagues, hey, you got to hear this.
Yeah.
That's when that was one of the moments, right?
Yep.
Another moment is when you get that publication in a significant significant journal, right? And everybody starts citing it. That when you write and receive your first research grant,
Yeah. That's a big one.
and you get back the peer review, even though some things aren't the best. Generally, you stood the test against against the rest of your peers,
the
either for a
critics.
funding grant or for a paper.
Yeah. The other big one for me was when Hansen et al. came out in a different paper. Whereas, they mentioned me by name in a publication. I'm like, yes.
Yeah.
That's another big one.
Yeah, that's right. When you get high-level, high-profile papers that cite your paper as part of the as part of the discussion. Yep, I agree.
Oh, man, I had one recently. I mean, we've been at FSU for almost 10 years now and working on photon up conversion solar cells. But there was a recent review article that came out, and it's covering everything. But it gave us 3 paragraphs, and I'm like, this is a body of work. It's no longer a line. It's actually a
body of work. Yeah,
it's a compilation of content, which is kind of fun.
We were just in a skirmish there, just a friendly hello.
And that's just warm up between games, is that?
Yeah, if you want. But generally, it's more of a meet and greet. And
yeah, that's fun.
all that.
All right, we should throw up a prediction because you have a bunch of really fun ones. What do you want to start with? What looks
I don't
interesting?
know. Start anywhere on there. And we were talking about procurement, so go to the second one there.
That's fun. All right, ladies and gentlemen, we're going to do a prediction. If you're not following, click the follow button. You'll get 300 standard internet units that you can spend on various things on this channel, like making us take a drink or requesting a factoid, but they are useless outside of this channel. Nonetheless, you should click that button so we have points, and also it helps with our visibility. We're going to pop up a science question. That's what we do on this channel with our predictions. We do science questions instead of gaming related questions. And so the question that we are going to pop up right now is, what's more expensive, 1 ton of liquid helium or 1 ton of superconducting wire? A ton of helium. It's a fun concept. But what's more expensive? And this is not a ton of feathers versus a ton of bricks. The one of them has an answer. One of them is more expensive than the other. The question is it 1 ton of liquid helium or 1 ton of superconducting wire? And so which one is more expensive? And so if you haven't done this stream before, at the top of your chat, you see a little predict button there. Click that predict button, and then you can gamble as many internet points as you want, one way or the other. Is it 1 ton of liquid helium or 1 ton of superconducting wire? Which one is more expensive? And note, you're on Ask a Scientist Gaming honor code, so you can look it up via Google or, oh man, you think ChatGPT would have an answer?
Yeah,
for this one?
it'll be difficult actually to look up. I mean, because they'd have to do math.
So if you guys can do the math in under, I guess we should let them. If they can do it in under 2 minutes, they've earned.
But I don't know if they'll be able to really dig into the details of the superconductor cost.
Yeah.
And of course, I just bought 30 tons of it, so I can tell you exactly how much we paid for those 30 tons.
I was going to say you get a discount on that kind of scale.
Yeah, that's right.
All right, you guys have about a minute left. 1 ton of liquid helium, 1 ton of superconducting wire. Which one is more expensive? And that's fun because we have actual prices.
Yeah, we had a helium crisis last year. Did you get burned by the helium crisis?
A little bit. Our NMRs, we have 7 of them in the department. So
yeah, NMR magnets ruled the supply for a while there.
I mean, the crisis is still real. It's just not costing as much right now.
Yeah.
So
it's alleviating because we have management of the Amarillo Reserve down in Texas now. And that was shut down partly because of safety concerns. Helium comes from natural gas wells. Why does natural gas stay in the ground? It's because it's got this geological cap on top of it, and so it can't escape. Well, that cap also works for helium, and helium comes from decay of isotopes and also primordial helium back when the Earth was a bunch of dust that kind of concreted together. So
I just love the fact that we get helium out of the ground.
Yeah,
it's counterintuitive, but there it is.
So the big natural gas complex around Amarillo, Texas, is nicely set up for us to store our helium in it. All the natural gas is gone, or so you think. And what was happening is that they were finding a little bit of carbon mixed in with the helium or methane, right? Yeah. And now you got a problem where that might be boom. You might get that in a condition where a catastrophe happens. Yeah. And actually,
especially high pressure and
well, flammable gas too. You got to build up. But what actually did happen in Russia was that the Azov reserve blew up. And that set everybody back. We used to draw helium from Russia as well, but that was when that set everybody back.
All right, Lance, what's the answer? 1 ton of liquid helium or 1 ton of superconducting wire?
A ton of superconducting wire.
So you have the numbers here. I'll read those out. 8 liters of liquid helium per kilogram, 8,000 liters per ton, blah, 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 blah. It's about 160,000 per ton for liquid helium. It is about 2 million per ton for superconducting wire.
Yes.
I mean, superconducting wire is a bit deceptive because it's typically very thin, right?
Yeah, that's right. About 1 millimeter in diameter. And you would think, okay, that should be kind of cheap. But one of the raw materials, actually, niobium, is not that cheap. But really what you're doing is you're paying for a manufacturing process that's rather difficult. And the quality control in that process.
Yeah, that makes sense. So you're paying about 10 times more for superconducting wire than for liquid helium.
Yeah.
What I love about that is any casual viewer of this stream could have no idea the cost of either of those guys.
But you only buy the wire once, right?
Point.
Then you build the magnet and run it.
Yeah.
And you may be in a situation where you're refilling or replacing lost helium, right? And okay, so that might be a recurring expense. Now, MRI magnets are really interesting because they get charged up at the factory, and maybe some of the listeners know what superconductivity is, but if you don't, it's friction-free electricity, right? It's perpetual motion. The electricity will keep going around a loop of wire forever and ever and ever. And so they charge up these large electromagnets for medicine at the factory. They're shipped at field, the current's going around the windings, right? And they have ways now of keeping them ever cold. They have reliquefiers that will take any of the residual heat and reliquefy and put it back in. So the only thing you need is electric power.
Yeah, that's
and if
pretty
you
amazing.
now ship it with a generator, you can pretty much deliver an MRI anywhere in the world,
Man,
which is fantastic.
that's crazy. They deliver them with the field intact, with current flowing through them.
Yep.
That's pretty amazing.
Yeah, 1.5 or 3 Tesla.
So how much semiconductor or superconducting wire did you say you bought? How many tons of
30
it?
tons.
30 tons.
Yeah.
Jeez.
That's nothing. I think we have another question up here about tons, but or maybe it's one of the factoids. But
which one is it? CERN? More energy? No. Maybe it's a factoid.
well, the amount of wire that we bought for it's this one right here, right? But the amount of wire that we bought for CERN, say the Large Hadron Collider, is something like 1,700 tons. And that was a one-time shot. The amount of wire that the magnetic resonance imaging industry goes through every year, somewhere around 1,000 to 2,000 tons.
Jeez.
They are working 24/7, three
Yeah.
shifts,
Yeah.
right? And after the pandemic, there was sort of a lag in a buildup of orders, and so after we got going, they got going big time, and they delayed all the other superconductor manufacturing to produce MRI wire because that's their bread and butter product.
Yeah. I mean, so how long does an MRI magnet last, or a coil?
I think they have 30-year lifetimes for ancillary systems, but we sometimes acquire not MRI systems, but NMR, chemistry, 800 megahertz nuclear magnetic resonance magnets that have been there for 20, 30 years that are inefficient on their helium.
Yeah.
Because we want the magnet inside, and we want to toy with the ideas of retrofitting those magnets with better magnets. And so we've got 2 or 3 or 5 sitting around outside the parking lot of the building that are destined at some date, as the technology advances, of getting its coils on the high field inside portion replaced with higher field coils to achieve new even higher fields or records for that configuration.
That's pretty fun.
Yeah, I couldn't get there. Darn it.
Up that
I'm
number
on my
again.
own. Let's get all
So
the way.
$2 million per ton, and you bought 30 tons of it. So you wrote a $60 million check. How do you transfer?
Well, not just me, CERN and me, right? But Fermilab was the other buyer for the U.S. So CERN bought their wire, and Fermilab bought the wire in the U.S. I have a counterpart at CERN, but the two of us basically determine, all the quality plan, and we're responsible for all of the characterizations and all of that. But the wire manufacturer also, in order to ship the wire, they had to do the initial characterizations, and they're responsible for the initial quality control. But every sample gets done twice to get the verification of quality. And I mean, you'd be amazed at, again, it's humans, right? And the important part about what made the procurement successful, it's 95% done. It's definitely a success. was the spirit of trust between us and the manufacturers, where we could candidly talk about problems and things that emerged on the production line. Had this been sort of a cutthroat MRI, type of transaction, that might not have occurred.
Yeah.
And there are unknowns. This is technology beyond the state of the art. So there are unknowns that emerge, and you have to work pretty hard to, understand what the impact of an unknown is when it actually does emerge.
Well, and their customer base for a purchase this large is relatively small, right? They have to work with you to keep you happy.
Yeah, that's right. And MRI's $2 billion, $3 billion a year industry, but science facility magnets is certainly not as big a market. Right. I mean, we're definitely trying to replace magnets at MagLab and build next generation magnets, but I think the total value of all the magnets at MagLab can be numbered into tens of millions, but not billions.
Yeah.
Right.
I mean, so how does the intellectual property relationship between you and that company go, or the MagLab in general and that company?
All the procurement is covered under a non-disclosure agreement.
Okay.
We can't teach anybody else how to make their product. We know their manufacturing designs, their manufacturing secrets, because they have to disclose it to us as terms of the procurement. And I got excited there. I got out of frame and started moving my chair around. But
No worries. You're in it. It's half the fun of Ask a Scientist Gaming is the gaming. So, Lorianne, a follow-up to that conversation, is that about accent northern U.S. or Canada?
Wisconsin. I grew up on the east side of Wisconsin.
A boot.
Yeah, I grew up about 40 miles south of Green Bay in a small town.
So I'm from central Minnesota, actually.
Oh, really?
So,
Minnesota?
Yeah. Yep.
Yeah, there?
Minnesota, yeah.
A couple, 2-3 beers, yeah.
Fargo accent. Most people don't catch it. That's why I was curious if Lori was referring to me or you.
Could be. Yeah.
So some people will ask my wife if she's from Canada. She still busts it out occasionally, but I haven't been caught yet. So unless Lori just caught the boot.
Yeah, no, I married my high school sweetheart, so we've been together 42 years already.
Yeah.
And, she's from the rival high school up the road by 6 miles.
That's what I love.
Another small town of 3,000 people, so you can imagine the scandal. Oh, the scandal.
Yeah, exactly. Right? It's
Okay, why am I jumping in here when the rest of the team is not? But
Capulets and Montagues, yes.
Yeah.
Or maybe the McCoys and the
Hatfields.
Yeah, there we go. That's a more accurate analogy.
That's right.
So I actually grew up in a town of 1,600 people, Fulton, Minnesota.
All right.
So yeah,
you're fully there with me.
Oh yeah, no, we had a cornfield directly adjacent to our football field.
I lived in the middle of a cornfield. That part of Wisconsin are divided up in 1 mile by 1 mile sections.
But here's the question: did you ever do corn detasseling for a summer job?
No, I didn't have to. I was lucky enough not to have to do that. Actually, I discovered after we moved in the middle of the cornfields that I was allergic to corn pollen.
That'll do it.
Yeah. So I thankfully did not have to do corn detasseling because that really would have knocked me out. But so mile by mile sections, and we were smack dab in the middle of it. So you get off of the bus in winter, you turn your back into the wind, you walk backward up a half-mile driveway to get to the house. Actually, it's about 600 yards, but it's still a long way.
Yeah. No, I'm actually heading back to Minnesota next week to give a talk at the U of M, and I'll visit St. Cloud State, my undergrad.
Fantastic!
So, yeah, it'll be fun journey home. We haven't been back. I mean, COVID put a damper on a lot of that.
Oh, so that means you can get to Surly Brewery.
Oh, yeah. No, if I have a day off, I could.
Their new brewery is wonderful.
Ethan Lambert has asked us to define corn detasseling. I don't know the formal process, but you take out the stem out of the top of the corn, and it stops it from. It basically allows it to continue growing.
Yeah. So the corn ears have the stamens, and the pollen comes off the tassel. So you prevent pollination of the corn.
Yep, and that allows it to grow bigger and more crop yield and things like that.
Yeah.
And you do that by the stalk. Yeah, that's why they pay a bunch of high schoolers to walk through a cornfield and go one by one and just pull it out the top and put it in a basket and throw it in a truck, basically.
Yeah. They used to pay us in high school to go pick apples at the apple orchard.
Yeah. It's not a great job, but for a high schooler in the small town in the middle of nowhere, it's not bad pay. So
I mean, my family were newspaper printers for 4 generations. So, we printed all the small town newspapers up and down the east side of Wisconsin because we had the printing press. And then we published our own small town paper. But, I grew up kind of, sweeping up the shop and then changing the ink out of the ink wells. And then a little later, when I got a little bigger, putting there's a 3-inch steel shaft that goes through a 1,000-pound roll of newsprint. It's 36 inches wide and about 4 feet high. And then rolling that thing up and leveraging it onto the press and, getting that thing going.
Yeah. Ken Xer, welcome to the stream. Thank you for the first time chat. It's a good thing Lance was allergic to corn pollen versus hops. Ask him about beer making. I don't know. We've talked about corn whiskey already tonight. So,
well, you're a chemist, right? So beer making is just biology and chemistry,
Yeah.
right? I mean, you start with malt, which is grain that has been allowed to germinate, and then the germination is stopped. Right, and it's stopped by heating it and kilning it. But what happens at the start of germination is that the little grain kernel makes some enzymes that will convert the stored energy into starch into sugars that the plant can use to grow. Right, so when you start brewing, you crush up the grain and you go through sort of mash of water and grain at different temperatures to wake up that enzyme and let that enzyme get to work on the starch because you want sugars. Alcohol comes from fermenting certain types of sugars: sucrose, dextrose, glucose,
lactose,
milk
sugar.
But I don't know of maltose or any of the more complicated sugars. Right, so those contribute to mouthfeel.
Yeah.
And by playing around with your time and temperature, and the amount of time that the grain is soaking in this hot water, at what temperature, you pick out a sugar profile and a mouthfeel profile and all of that. Right, and then you add your strain of yeast, and the strain of yeast, turns it into alcohol, but also gives it additional flavor profiles in the fermenter. And then, you can go. After you mash and you wash out all the sugars, then you have a hop process where you're extracting the alpha acids and the beta acids from the hops by boiling them.
Not Dairy Neutrino, welcome back to stream. And yes, we do have a modern game. We're playing Overwatch 2 with Lance Cooley. He's actually on a team right now with his daughter, so it's kind of fun.
Yeah, sometimes my daughter whispers to me in the ear, 9 o'clock, 3 high.
She's taking it seriously. I respect that. But welcome back, Non-Dairy Neutrino. So follow up on the alcohol and brewing. So there's a contingent of people that would argue a wine is like in its purest form, it has to be brewed a certain way. But if you could take an HPLC and recreate all the components just from adding things together, like a chemical composition means, do you think it's the same?
No, it isn't. And so there's a whiskey called Glyph, which is basically a chemical synthesized product. Right, and what they miss, I think, is some kind of a synthesis of different molecules that give mouthfeel and complicated flavor profiles, and I think it's combinatorial things that can't be simulated. I can imagine as a chemist they run things through a gas chromatograph, see what's there.
Yeah.
But
so you think there's subtleties they're not catching in that?
Well, I'm sure because I've tasted Glyph. It's not exactly what I'm looking for.
Yeah.
And it's missing certain of the complex toffee, especially sort of the whiskey wood interactions. And the same applies to beer. I mean, there's more complicated interactions that go on with the with the wood and with the other things that go along for the ride besides the fermentable sugars and the alcohol.
So they haven't done it yet, but you think it's possible? I mean, with the right combination of quantification, or is the parts per million too small to add?
I don't think so. And remember, half of the tasting experience is emotional, right? And I think anything that presents itself as this is artificial is just going to put you off emotionally.
Oh man! So next time we need a blind taste test.
Yeah. Well, blind taste tests are punishing.
Exactly.
Yeah,
Well, the wine community is devastated by those.
Yeah. You think your favorite and the one you love is going to win, and then it comes out and doesn't even get to your top three. You know? Yeah. So but blind taste, we do a lot of blind whiskey taste tests. You know, just because it helps you kind of pick out discerning notes in different flavors, right? It helps you.
Yeah.
It helps you. Yeah, training. That's right. Be a little critical of what's in what you're tasting, and decide for yourself what you like, not what's in the flavor profile, right? And sometimes my neighbor Kyle. I hope he's listening. Kyle and I will have whiskey every night, and we started sort of just sharing bottles out in the driveway in the pandemic, and it grew to, I think we had 220 different whiskey tastes that first year, and now we're somewhere around 500, and we've got a grand collection. But it started out where, well, I'm getting this wonderful green apple and Japanese tea. Well, I'm getting graham cracker and cream and a little bit of honey and nectar, and going from there. And okay, well, you got something different. I got something different. We're both right because we're both describing what it is.
Yeah.
But then a little later, we kind of started converging on tastes until we got to blinds, and then basically my top three were his bottom three, and his top three were my bottom three, and it's like, oh boy,
that's awesome.
Right? So we got to recalibrate yet again, and.
Well, I still have appreciation. So, like, my wife and I last time we went to Disney, we did a date night where we did a tequila tasting, and they have like the I don't know what.
Yeah, tequilas are wonderful. Yeah,
but he was from Tequila, Mexico.
Yeah, right.
Like an obvious expert in this, and like walking us through and all these things you never recognize unless you are aware of it. Speaking of which, Reese's Pieces is redeemed. Take a drink. So, cheers, Lance. Reese's Pieces. Thank you for joining us.
Yeah.
As always, hopefully you guys have something in front of you. Probably not additionally aged whiskey, but if you do, cheers. Enjoy your night. Wednesday night drinking science, playing some Overwatch too.
Yeah, usually we are blogging and reviewing we don't really have a blog. We just kind of post on Facebook, but we're doing Whiskey Wednesday. So you're amplifying my Whiskey Wednesday right there.
That's awesome. Hopefully they'll swing by the stream. Speaking of which, Lorianne has requested a factoid. Do you have a knowledge bomb you'd like to drop on the audience?
Knowledge bomb.
That's I
got tons of knowledge bombs.
Let's do it.
All right. So, one of the things that we are working on right now is a group of magnets called little big coils, right? And these are a type of superconductor, REBCO, rare earth barium copper oxide, which comes in a tape, and you wind the tape up like an old cassette tape. It's a flat pancake-shaped disc, and we call it pancake winding, right? But you can pack the turns in really tightly, which means you can pack the current really tightly where you need the field. So little big coil is actually the world record holder right now at 45.5 Tesla for a DC field, and not the 45 Tesla hybrid magnet at MagLab, right? Because we put a stack of these magnets inside of a resistive 31 Tesla magnet for the background and got the 45.5 Tesla sustained. All right. Now, that technology is far from it's not a technology. Those are little research magnets, but they are far from their limit. We're presently trying to push to 50 Tesla. And just because we are working with manufacturers to maybe try and get higher current density, more amps per turn, so more field. I hope Griffin Bradford is listening. He's the next rising star graduate student who's going to make those magnets, and he'll be the next world record holder. Called up Guinness now, I predict it.
Is there actually a Guinness category? There should be.
There should be. In
actually,
DC field.
That'd be an amazing PR for the MagLab, actually.
Yeah.
Bring them out and...
Yeah, it was a Nature paper in 2017.
Yeah.
Unfortunately, or maybe fortunately, it happened at about the same time as our 32 Tesla user magnet made its maximum field, and so there are multiple headlines that got conflated together. If I'm the controller of information, I kind of like to space them out and keep the publicity buzzing, right?
Yeah.
But yeah, this was a 2017 result. I think it finally made it into print in 2018, but it's ongoing. So Little Big Coil, 45.5 Tesla world record. That is the factoid for you.
I mean, so this kind of ties to one of our regular questions we ask. So, I mean, there's been Nobel Prizes for MRI and NMRs and various different, I mean, making the next big magnet, room temperature superconductor, presumably that's the next Nobel Prize in your field? If you had to guess, what would
Nobel Prize, yeah, so room temperature superconductivity could be a Nobel Prize. Mechanism of high temperature superconductivity, also a Nobel Prize. The two, I think, are different. I think the literature is showing that they're different. Room temperature superconductivity is metallic hydrogen. It's hydrogen that's been put in a metal lattice. The metal lattice kind of squeezes it together. One of our research faculty, Stan Tozer, is working on that. I hope you have him as a guest.
I should.
We were talking about that before we got on the air here, but you know, you do this experiment by taking a 3+ metal ion that can form a hydride and squishing it between diamond anvils.
Yeah, as long as you press it hard enough.
But gigapascal, right? You know, thousands of atmospheres. But as you're pressing it, the structure of the material changes, and when the structure changes, it can accept more hydrogen. And so as you add more hydrogen, you start forming enough hydrogen where you can have metallic hydrogen in this cage. Okay. The way superconductivity works, one of the ways to increase the critical temperature is to use light atoms. It depends on the mass of the atom. So hydrogen is the ultimate in the mass of the atom. I think we have computations from Warren Pickett and from others that Neil Ashcroft, perhaps, who we all had in solid-state physics, that if metallic hydrogen could exist, then it might have some very special properties, such as room temperature superconductivity. And I think that day has arrived.
Yeah.
The problem is we might not use it at room temperature. Properties get better as they get cooler. So
I see. It's not
we will
optimized.
probably aim for the best properties at lower temperature.
Yeah. But I mean, it's much easier to reach those temperatures with...
Just a household-like refrigerator. Right?
Yeah. No, that's pretty fun. I mean, so is that one Nobel Prize, or is that partitioned into two? I guess it depends experimentally when they verify. And
It's a good question. Maybe a Nobel Prize for the class of materials and the idea for caging the hydrogen between metal cations. And then there could be another Nobel Prize for understanding the evolution of those structures as pressure goes up.
And so this ties into non-dairy neutrinos question. Have we already talked about the recent paper from Quasi-Cranks claiming room temperature superconductor? And we actually had this up in Discord, actually. So Lance is familiar with this paper. I think this is the one you're talking about, if not non-dairy.
Yeah, there's multiple competing groups. Aramet's group, I mentioned Stan Tozer, but his publication, I think, is under review still.
Yeah.
And there's other teams working on this.
Yeah,
right?
so this Diaz paper, evidence of near ambient superconductivity in an
with nitrogen
lutetium hydrogen.
Right. But
Or hydride, sorry.
Yeah, it's a 3+ ion. Lutetium's a 3+ rare earth. And again, you're caging the hydrogen, but other people are doing the same thing. One of the hallmarks of a discovery, why does CERN, or the Large Hadron Collider, have two interaction regions and two detectors? Because they're independent, and when you're claiming a discovery, both have to have found the same statistics and the same result, very similar results, right? And that's what was verified when the Higgs boson was announced, for instance, right? So the same thing applies here. You have multiple groups able to synthesize something, but remember, the structure changes as the material is being squeezed. So it's not like you can synthesize it and then send it around to another lab, right? Because that lab has to have the ability to change, to apply the pressure and allow the structure to change in the same way. And it doesn't. It changes in different ways, as far as I understand, right? So it's a difficult way to have reproducibility across different labs. But you have multiple groups that are working on a problem and getting similar results with similar classes of materials, namely a 3+ ion with hydrogen, squeezing it, emitting more hydrogen, and observing the properties, which, by the way, is also damn hard to do. We've had a number of unidentified superconducting objects that really were the result of something that was insulating and became metallic, and it displayed a very steep drop of electrical resistance, and that's a completely different thing.
See, on this paper, they claim superconductivity at 294 Kelvin and 10 kilobars, which is 10 atmospheres, right? That's direct.
Yeah.
So it's almost ambient pressures.
Almost. That's right.
They're getting much closer.
Yep.
I mean, so do you believe these results? I mean, you don't have to overtly state one way or another.
I think the results are reasonable. I know there's now. I know the reviewers of the results are carefully scrutinizing, is the data authentic, and various premiums of scientific ethics and all of that, which is very important. And I don't want to speak to that, but in my opinion, the fact that you have multiple groups kind of getting the same types of answers, right, points to something real.
I mean, so how much of a game changer is this if this is real? I mean, does this change the way you guys do business and engineering and applying these, or is this just a step towards a useful material?
Not much of a game changer for applications, because it's a huge hurdle to get a material that only exists under pressure into a practical form like a long length electrical wire.
Oh, that's interesting.
How do you put gigapascals on a wire? I don't know. Right? Either your application has to be in that enormous pressure all the time, even while the application is being made, or, I'm going to die, okay, or something else. Now, what the solid-state physics community is very good at doing is contriving charge and spin to affect structure, right? Charge in the electron and spin in the electron to affect structure, and then use that somehow to produce, let's say, atomic or molecular or crystal structure pressure, right? So it may be possible to invoke pressure by magnetic coupling or charge coupling or something like that in the material that is, better than ambient, right? So now the challenge here is that it means there's going to be perhaps some enormous internal stresses and strains in the material. But we've also encountered those problems with steels, and maybe there's a way to to apply material science and figure that out.
I mean, so this is a different level of abstraction or way of thinking about the problem, because as a chemist, I think of, you have a sample, you have a bulk sample, you're testing a bulk property, but you're talking about turning that into a wire, coiling that wire thousands and thousands of times,
right,
keeping it in some isolated environment, and that's just an engineering nightmare, presumably.
Yeah, another factoid, there's only 5 conductors in our portfolio of available long-length wires, even though there's 40,000 superconducting materials and counting.
So that's any MRI on Earth is made of those 5 things?
It's made of one, niobium titanium alloy. We do not have niobium tin MRI magnets. It was dabbled with for a while, and we certainly don't have high-temperature superconducting wire niobium or MRI magnets.
So you mentioned 5. What are the other 4 used for if they're not in MRIs?
So niobium titanium alloy is 95% of all superconductors being used on a tonnage or price scale. Niobium 3 tin is the other 5%, and niobium 3 tin is used to get from about 9 Tesla to about 20 Tesla. And then beyond 20 Tesla, you have to use a high temperature superconductor, which is a high field superconductor at low temperature. And there we have 2 bismuth oxide or bismuth cuprate variants, and the rare earth or yttrium barium copper oxide tape conductor, which is very widely used because it's conveniently made in a ready-to-wind tape, like I was talking about before, this cassette tape. a little big coil conductor.
So that's a nice transition to our next prediction. If you guys aren't following, click the follow button. Let's spend some standard internet units on our prediction. Right now, we're going to throw up a science question. We're going to ask you guys, what is the #1 use of superconducting magnets? Is it for research or is it for medicine? This is in terms of both distance of coil and dollars spent, presumably on materials. What is the #1 use? Is it in research, things like particle accelerators and NMRs and chemistry labs, or is it in things like medicine where they do MRIs?
Yeah, this should be an easy one now that we've talked a little bit about it.
Well, I think it was a good follow-up on that one. So, if you guys haven't done predictions before, click the predict button. You can bet as many standard internet units as you want. We made up a metric for our internet points for this channel. But yeah, what is it used for more? Research or is it medicine? Have you been paying attention to what Lance is saying?
By the way, how did the bets come out in the previous question?
It was 1-1, but they bet more for the correct answer, the superconducting wire.
Oh, good for them. Yeah.
So what's fun about the predictions, I don't know how much you've done it on Twitch, but you can not just pick an answer, but you can gamble as much of your internet points as you want, and so you can weight it accordingly.
Yeah, nobody went 10-1, and
we have a dark horse.
You could have been sure.
Where's Cuddle Puppy when we need a dark horse bet?
That's right. That's right.
Those are some of the best. It's fun. You'd appreciate. Jim Fadul had the biggest payout on one of his predictions, and it was
the record.
It was 250-1 payout, and it was when was hops first incorporated into beers? Was it before 600 AD?
No, it was late. Beer was not hopped for a long time.
Yeah, so you would have done well on that one. Yeah. So most people assumed it'd been there for a long time.
Hops are a preservative, but it was really discovered in association with the India Pale Ales, I think, where the beer had to survive the trip around the Horn of Africa.
Yeah.
High alcohol, high hops.
Maintaining. You guys have about 10 seconds left. Research versus medicine. Somebody do a dark horse bet. Everyone has bet medicine so far, so we'll see how this one turns out.
Yeah,
good 5 seconds. No, you can't give that away.
5 seconds. Come on, I can give it away.
All right, no one's betting the dark horse. So the answer in this case is, in fact, medicine.
Yes.
And so it's MRIs. That's the #1 use.
Yeah, 1 particle accelerator per year.
No, 1 particle accelerator per year on MRIs.
Yeah.
I mean, medicine is an expensive, lucrative business, so makes sense.
We all need to be examined and fixed and from time to time, right?
I mean, so how fast is that technology advancing? Like, if you said resolution of an MRI now versus 20 years ago, is it?
Not very fast at all, because it's risk averse.
Huh.
Okay, but we're in the middle now of a time when our national academies will convene panels to think about the grand challenges and the grand ideas for magnets and grand opportunities. One of the grand opportunities is a 20 Tesla human MRI, because you can map out intelligence. You can map the pathways of neurons. So at about the neurospin outside of France in Saclay, right, is able to, I think there's 17 Tesla on the magnet and 11 Tesla in the body. They can map to the cellular level of the brain and kind of see what lights up and all that. And so imagine MRI lie detection.
So what is an MRI right now? Typically, that's like 3
Typically
Tesla?
3 Tesla, 1.5 and 3 Tesla.
So if you get up to 20 Tesla, you can really start.
Well, you have some 7 Tesla research systems. I think 11 Tesla on body is the record research system. Okay, that's the neurospin system I was talking about.
Yep.
Right, but the higher the field, the smaller the spatial resolution that you can look at and do medicine and do science with. But above about 5 Tesla, you really need to have the patient sedated, because if they kind of move their head or whatever, they get completely disoriented from the eddy currents in the brain.
Oh, wow.
Right?
That's a fun factoid.
Well, okay, so the FDA has not cleared anything for above 3 Tesla.
But people have played with this.
Yeah, I think in Europe you can have sedated patients, and it could be in the U.S., you can have sedated patients at 7 Tesla.
Wow.
Okay. And you'd want to be sedated anyway for that field, but at that stage, you see cellular level type information, and then I think at 11 Tesla on body, which I think is 20 Tesla on magnet. I'm kind of just pulling these numbers out of thin air, but from the best that I know. but I think at that point you actually start seeing the wiring of intelligence. And like I said, so lie detection by MRI, you see what lights up at a cellular level. And you can take a patient that might be, in a medically vegetative or non-responsive state and ask the patient questions and see that parts of the brain light up, and a different question, different parts of the brain light up. And then you ask the question, is the patient really responsive or not? And that's a debate that's going on.
Yeah.
But then you get to where, how are all those cells wired together as, the biologic source of consciousness, or is this a grand quantum computer, or just exactly what is? Oh, geez, I got to get out of here. I'm dead.
Grand question.
Yeah.
Man, that's intense though when you're talking about eddy currents within brain tissue.
Yeah.
Because you're reaching a threshold where you can start manipulating thought depending on the magnitude of the field you apply and the direction.
Well, the patient moves their head. They'll get a pretty bad sensation from the byproduct of moving their head.
Yeah, no, that's intense to think about.
But at 20 Tesla, we're into unknown medicine. Right, which is kind of okay. We want to push the frontier of behavior. We want to understand various Alzheimer's, various cognitive disorders. Imagine what we could do with something like that. But the other grand challenge really is a system that is small and portable and still the 3 Tesla, but where you could drive it around Africa, or even drop it in by a small aerial vehicle or something, where I was concentrating too much there.
No worries.
And do infant MRI, so a very small bore, but not a low temperature superconductor at 3 Tesla, but a high temperature superconductor with its own little refrigerator attached and all that. A small bore MRI that, especially for infants, there we go, got it out, in remote places, and make that type of medicine widely accessible.
I mean, but speaking of pushing the edge of that, like MagLab seems like a well-suited place to start pushing MRIs further, especially given that FSU is pushing towards the health sciences and the medical facilities. I mean, do we have a contingent that's pushing that? Like how far we can go with MRI?
We don't have an MRI contingent at MagLab. We have an NMR contingent at MagLab.
But they have wide boards. They put mice in them.
Yeah, absolutely. Mice and ferrets and whatever. Yeah, that's the 900 megahertz wide bore. But Professor Joanna Long, who's at the University of Florida arm of MagLab, is the one of the leads for...
we want more?
Oh, yeah.
Let's keep going.
My daughter Louise just texted me, we just maxed out in overtime. That was a hell of a win, actually. Yeah, no, so MagLab has a strong presence in NMR, not necessarily a strong presence in MRI, but we are forming industry partnerships with the different companies of the big players, partly because, these grand challenges. Okay, you want an infant capable system that's portable, that... and infants are small, a small bore system that could be something that's easily built, and springboards are high temperature superconducting technology.
Yeah.
Right. And it'd be, again, sort of a closed function system where you have a closed cycle refrigerator attached to it. You wouldn't have to depend on liquid helium. It's just, you could drive it around in a truck. All you need is electricity.
I mean, so when you say closed system, that's like thermoelectric cooling, or how do they?
Yeah, cryo cooling. It's a closed circuit, self-contained.
But it's still helium
system. It has helium inside the system. Yes.
I see.
But
but it's closed loop and
and extracts the heat. You're really not running this magnet up and down at field. It's sitting at field, so the losses that it develops are actually really small. Right.
Yeah, that's intriguing.
We're unranked. Olivia's put us in somewhere else. I got.
All right, everyone. Anyone just joining us today? Ask a Scientist Gaming. We have Dr. Lance Cooley, who's an expert in superconducting materials engineering, their application. He's happy to answer. He's the director of the Applied Superconductivity Center at the National High Magnetic Field Laboratory. So yeah, he's happy to answer any questions related to magnetism, superconducting coils. This could be everything from MRIs and NMRs to particle accelerators, which he's involved with.
Yeah, we could talk about particle accelerators. We could talk about fusion reactors. We have a significant program in fusion.
We also have a non-trivial contingent talking about alcohol tonight. So non-dairy neutrinos has a follow-up on a previous conversation. Wasn't honey and the mead the first alcohols?
It could be, yeah, it could be Egypt 5,000 years ago. Yeah, I would vote for that. Yeah, that's a good comment.
I mean, somebody recovered something at some point, right? From they found honey-based mead that was 5,000 years old.
Yeah, honey is one of those magical materials, right?
Yeah, it sustains.
Yeah,
sure.
you know what it sustains and all that.
Mm-hmm. I would be curious to taste that. It would be terrible, but like just for
it might be black, might be oxidized. Yeah,
it might be toxic. But how many people can say they've tried 5,000-year-old alcohol?
Yeah, right, exactly. No, I have not made mead. Mead would be fun to make. Mead is honey based. I'm not set up for it.
Yeah, I was going to say there's a non-trivial activation barrier towards any of the brewing strategies, right?
Yeah, right. That's why it's a hobby and you have fun with it, right?
Yeah.
And you can't cheat. You can't go out and buy those turnkey beer gerator systems, right? That just you dump in the grain and it makes it for you. No. You got to build it. You got to build it out of buckets and pails and copper pans and silicone tubing and a pump and your own little thermocouples or meat thermometers and.
And a small army of 1,000 YouTube videos.
Yeah,
You're there.
Yeah, that's right. Charlie Papazian's Joy of Homebrewing, right? Way back in the era before the internet.
Yeah. Back to the science. Non-dairy neutrino wants to know, one question I've always had is what strength of electromagnetic field that a human would start feeling it?
Yeah, I certainly you would feel it, I think, at 3 Tesla, but I think it's not significant to be disorienting, and that's why the FDA has approved 3 Tesla for human MRI. But I've heard anecdotal evidence that at 5 Tesla, if you move your head, you get swimming disorientations. Vertigo that's hard to recover from. It's really
people walk within the NMR radius at the mag lab, right? Do they describe feeling that?
No, but that's 100 Gauss.
Okay.
Right, that's not in the bore of the magnet. So
I suppose
right,
you're
in a low field in a low field region, and there are strictly defined and observed and patrolled field barriers.
I see.
Right. Partly because you have other problems. So if you have a magnetic object, you don't want that thing to become a projectile and injure yourself or injure the magnet or injure something else and or somebody else in the lab.
I mean, that's such a curious phenomenon because like music and movies have long learned that there's subaudible sounds that make you feel discomfortable.
Yeah.
Right. Like you don't formally vocalize them in your ear, but you can feel them. Like is that the same kind of discomfort? Or
no, from what I understand, it's a because eddy currents are swirling in your brain. It's a completely disorienting feeling.
It's just
I don't want to try it.
Messing with your thoughts,
right? There's maybe one person or 2 people that reported it, because they're the ones that experienced it.
Yeah.
Way back in the early days of particle accelerators, they used to. There's tales, and I can't verify whether they're true.
The head in a beam.
Yes, the head in the beam to verify the position of the beam by seeing the sparklies, the Cherenkov radiation.
In your eyeballs.
Yeah, exactly. Yeah.
Wow.
Yeah, and I think this is the same type of lore that we don't want to reproduce.
Yeah.
Yeah.
I mean, it's a question of if it's bad for you and it's not known, right? That's why the FDA
No, well, so there's no known magnetic hazard for biology because there's no known coupling between DC magnetic fields and biology. Maybe AC fields and high frequency fields, but not DC fields in biology.
But
Right.
they won't approve it until somebody demonstrates a high utility use of it and shows it's not.
FDA is protecting us in terms of public acceptance, right? You know, so we ought not to, you know, disagree with their processes and their methods.
Yeah, no,
Right.
but it's one of those. I mean, I guess we'll follow up with one of our standard questions. That, you know, if you had unlimited budget and no moral qualms, what would you pursue? I mean, massive particle accelerators, a human MRI at 20 Tesla. What do you want to see? What do you want to know the answer to?
Well, so Breakthrough Energy has answered that question, but not my answer, right? But they're investing in fusion at billion-dollar scales right now,
That's crazy.
right? Because, you know, fusion is building a star on planet Earth.
Yep.
You know, potential very compact power source. A challenge with wind and solar is that it's widely distributed, and being widely distributed means that you lose control over which way the grid is trying to push electricity. You kind of want the grid to push electricity and make it go to where the load is, right? So you know, if it's distributed everywhere, which way does it flow? It's like a puddle. It's like a flat puddle. There's no slope, no place for it to go to. Centralized generation is a way for electricity to have a flow and to move out to, you know, be distributed around the, you know, subdivisions and cities and whatnot, right? So, you know, that's an important thing. And in a sustainable electric grid, where you only, basically the only highly centralized generation is hydroelectric in the absence of anything nuclear, you know, so fusion really is playing a very essential role. And I'm grateful for companies like Commonwealth. Sorry, I had to dodge the dragon. Yeah, but companies like Commonwealth Fusion Systems, they're you know, using the $1 billion from Bill Gates and Jeff Bezos' Breakthrough Energy Fund to go after this question of, can you build a privately funded fusion power plant? Right.
And so if you had that checkbook right now, you'd start a Manhattan project?
Yep, a Manhattan project towards fusion. But the other thing that I am really an advocate of, and I'm biased a little bit because we have a zero-emission aviation grant, is hydrogen as a liquid fuel. Right. You know, fuels are the great things that are transportable. You make them at one place and you bring them around and use them in another place.
They're high density.
Yeah, and high energy density.
Yep.
You know, and compared to batteries are wonderful too, and we need better batteries. But I think, you know, the solid state nature of battery ends up making it too heavy to be exquisitely portable as an energy carrier.
Yeah, you can't fly jumbo jet on a battery.
Exactly,
It's just
right.
impossible.
And we're trying to fly a jet on hydrogen, on liquid hydrogen, you know, for the energy density.
So you're interested in storage or generation or?
All of the above, you know, production, storage, generation.
Yeah.
You know, if I had to do it, it would be the you know, collected package of how do we research, develop, demonstrate, deploy, and then, you know, convince and obtain the public buy-in to an economy that, you know, we can make sustainable like this. I had a big moment there. I was levitating. The gravitational flux was raising a whole bunch of people there.
No worries. Non-dairy neutrino looked it up. Anatoly Bogowski. had his head downrange of the proton accelerator. He lived and just said he saw a flash of light brighter than 1,000 suns, but
Yeah,
no
the
pain.
sparklies. Yeah, yeah.
Wikipedia, 200 to 300,000 Rontgens.
200 kilorentgens of radiation. Boy, he didn't last long after that.
Yeah,
Brighter Than 1,000 Suns is a great book to go look up and read, by the way.
Oh, that's the title of a book.
Yeah, it's about the hydrogen bomb.
Oh, wow.
Yeah. And I recommend Richard Rhodes' book about the making of the atomic bomb, too.
Brighter than 1,000 suns.
Yep.
There's the book, ladies and gentlemen. We got a Wikipedia link right there if you're interested.
Oh, yeah.
What was
Yeah,
the
that's
other
a
one?
well-known book. Yep.
Making of the Atomic Bomb. What's the title of it?
Richard Rhodes, yeah, I think it's The Making of the Atomic Bomb. Richard, Rhodes.
Oh, making. They had it.
Yep. Yeah, you probably got it there, yep. That was a wonderful book. The first half of the book is sort of the history of atomic physics, or history of physics, through the magical generation between 1880 and 1920. The Einsteins, the Diracs, Marie Curie, all of the discovery of the atom, discovery that the atom has structure on the inside, discovery of quantum mechanics, all of that stuff. That's the first half of the book. It's a wonderful part of that. And then going into the Manhattan Project, and the near and dear to my heart, the experiment under Stagg Field at the University of Chicago, and then the development of the Department of Energy Manhattan Lab Complex and all of that. I'm anxious for the movie Oppenheimer, which is going to be coming out soon. That'll be interesting to see.
No, that's really fun. I mean, it's going to be so dramatized. And we'll see how true they stay to the science. That transitions to another one of our standard questions. I've watched a lot of movies, and obviously I'm interested in all domains of science. But we watch movies, and sometimes we're like, they got the science right. Sometimes we cringe on how bad they got it. So what movie or TV show has gotten your expertise right, and what has gotten it wrong?
Yeah, so Terminator, one of the Terminator movies, I think it's Judgment Day, where they had a particle accelerator. Right.
You pulled them on it, yes.
Yeah. that actually got it a little bit right. It ramped up too quickly, but the magnets there do ramp up, and they do have pretty substantial fringe fields. And if it's a magnetic substance, it would just kind of stick to the side and not be able to come off the side of that magnet. So I like the way that they did that.
So that was like a 10-second ramp up, but really it would be hours?
No, so the way the accelerator works, an accelerator is like a freight train with a bunch of coal cars. The coal are protons, right? Bunches of protons flow down the machine, all right? But what they have to do is load the protons from the pre-accelerator stages into the main ring before they ramp up the main ring. So the ramp rate is really more determined by the loading profile.
I see.
And at Fermilab they have antiprotons, not protons. But that's really more of what determines the ramping of the energy and of the field in the magnets than what they could actually withstand. Right? So it's really much less than what was depicted in Judgment Day, right?
That's fun though.
Yeah.
So you saw that moment and you're like, they did.
Yeah, I can agree with that. I've experienced, screwdrivers attached to various things like that, and they can't pry them off. I had a moment when the National High Magnetic Field Laboratory was still in Cambridge, Massachusetts, at MIT. I had a moment where our sample probe became dislodged from the magnet, and I had to climb on top of the hybrid magnet at 30 Tesla with an Allen wrench, magnetic Allen wrench, to try and tighten the bolts back down to get our probe back centered into the apparatus.
Did you feel it? Did you feel anything?
It was like holding a 30-pound Allen wrench and trying to fit it into the delicate head of a screw and turn it and not drop it because of the bad consequences of dropping it and maybe causing a quench of the magnet.
So what would have been the surface field there? I mean, it's an exponential fallout.
Yeah. One over R squared at the top. I was above it, right?
Yeah.
And maybe it's 1 over R cubed.
I'm curious what your brain felt.
My brain was fine, but I mean, if you watched the recent Veritasium video for that was, you know, they came to MagLab and looked at.
Yeah, I saw that they were throwing footballs across.
It like that, but you know, even at 100 Gauss, a magnetic object can have a force of many newtons, right? And you know, it can be stuck there in a way that it's immovable, right? This was movable, but I would say the field was the same as the very powerful refrigerator magnet, a tenth of a Tesla, something like that.
Okay. That makes sense.
Yeah.
Sorry, non-dairy neutrinos had a follow-up on Anatoly. Evidently, he went on to have no degradation in his mental capacity, but his physical well-being began to suffer. He had hearing loss in one ear, paralysis of half his face, and occasional seizures. Whew.
Not good.
Yeah, exactly.
Yeah.
I mean, there's irreversible damage. The human body can only replace so many things.
Yeah.
So tearing through that much tissue is absolutely devastating. All right. So Terminator 2 got it right.
And Hunt for Red October, maybe.
Oh, interesting.
Okay.
That's a fun.
Yeah, because, you know, there's continues to this day. So in an accelerator magnet, you've got a 10-meter long pipe, right, with the fields arranged so they flow, let's say, from top to bottom, okay? And because they're flowing from top to bottom, the charged particles are going down the tube, they bend into third axis, you know, across the width of the tube, right? That's what steers them around the beam, around the tunnel, right? But if you have seawater and you have two powerful electrodes and you apply those electrodes to the seawater, you can do the same thing. You can make it squirt out the end of the magnet.
Yeah.
Okay, so that physics was correct, and the magnitude of the fields required was about capable in that technology. You put an accelerator magnet on a submarine, and the guy comes up, you know, with the cable. It could be the superconductor, it could be the liquid helium, whatever. You know, that was all about right.
So they talked to a scientist. They got legit.
Or they read carefully, or whatever they did. Right.
That's fun.
All right. So
I did not expect that. Hunt for Red October. That's a first.
Yeah. But then what got it wrong?
Yes. What made you cringe?
Yeah, I got to think about that a little bit.
I mean, I'll give you an easy one. Magneto from X-Men.
Yep.
Fall off. Christian Beekman brought this one up, actually.
Well, but you know, there's the unseen psychokinetic magnetic force.
Yeah, whatever
right?
it might be.
That's in the video game I'm playing. Sigma has to control gravity.
Well, that's one of the things we talked about too. Is when you think about these superhero or whatever abandoning the rules of physics, like what rule do you have to abandon for that to be allowed?
Yeah,
or Magneto would have to be like the distance dependence, or somehow he can remotely affect fields or something.
Yeah. How does he tunnel to a? Yeah, exactly. I like cartoon physics even better. You know, how does Roadrunner stop in midair, and then Coyote not? Right.
No one has brought up Roadrunner yet, but it's a good point.
Come on. Cartoon physics has got to be part of a basic education.
Well, I mean, you could have also invoked Fast and the Furious franchise with the same principle behind it, because Newton be damned. No momentum in those worlds.
Oh, no, hold on. Pardon me.
No worries. Oh.
Oh, I see. You know, chat is looking at us. Our faces getting redder and redder.
Oh no,
playing
this
and the
is
play getting even worse.
So I didn't warn you about this, but one of the things
I knew it was coming. Come on.
Well, no, one of the reasons I love doing this is, one, video gaming is a very humanizing experience because we're not good at them for the most part.
Exactly.
But two, doing that while drunk, like we're just hanging out, playing video games, drinking alcohol, and just so happen to be experts in a particular domain.
Yep.
And so I think I really love that humanizing aspect.
Exactly. It makes the expert approachable, human, right? It makes the problems common, and that's what's needed to communicate the benefits of science.
Yeah, this knocks down the ivory tower in very specific ways. So no, I love it. All right, non-dairy neutrino has another follow-up. What? Oh, this is okay. This is a very specific question. We'll start with one of our general ones. What's your favorite equation?
Ampere's law. Because it's what makes magnets go.
That's it. Just Ampere's law. No, I mean that's what's fun about this question is usually it's a very elegant, simple.
Look what Olivia did. Dude. We're on a random character draw. I've never played Junkrat. Now I'm dead.
Oh wait, it picks for you?
Yes, it picks for you.
Oh my god. Well, Olivia,
my
thank you for the entertainment
Thank
value.
you, Olivia. This is high entertainment value here. Oh, there we go. All right, now I'm widow. No,
I mean,
that's
this is
good.
kind of
All right,
fun.
so I'll go up.
It forces
I'll
you
go
to
up high.
learn the characters.
Yeah, exactly. But
Can you
I
play this
stayed.
rated or is this just casual?
This is no. This is casual, yeah, but you know.
I want to see somebody
So
really
I got
good
the sniper
at this.
here. So let's see if I can pick somebody. Now they're flooding me, but oh come on, Lance, pick off a head. Head.
Oh, Olivia. Putting her dad through the ringer on Twitch stream live.
Yeah. Oh, this is
awesome.
five stars for Olivia. You know, doing this to me.
All right. So favorite equation, you have Ampere's equation. Another question, what's your favorite form of the electromagnetic field equation? Maxwell's integral, vector differential, potentials, four potential, Clifford algebraic. I know what half of those things are.
Yeah. No. So you know the vector calculus Stokes theorem, right, gives us the full curl. Right, and you know the vector expression is the important expression that applies to magnets that gives you the stresses that build up in magnets. You really got to pay attention to the three-dimensional tensors of field and current where they're going. You know, we have superconductors that you know they twist. You know, when the field interacts with the currents in the superconductors, there's a mechanical response, but it's a three-dimensional response, and you have to worry about the body forces and everything else. Right. So yeah, definitely the vector curl and the vector calculus of Maxwell's equations. Yeah.
That's awesome. I mean, it does matter. I mean, I really like the engineering aspect of it, and I guess this ties into what I assume is going to be your answer to one of these questions. Is there's a lot of force fields associated with magnets. What's the biggest accident or mistake you've seen in lab?
Oh, we'd like not to have any mistake.
Absolutely,
right?
But we do.
Yeah, and so quite often, you know, especially in the early days when helium was even more expensive than it was now. Why am I going after a tank as a support? I don't know.
Science question.
Okay, so if you quench a magnet, quenching is an interesting phenomenon. It's an uncontrolled thermal runaway of a superconducting magnet. But back in the days when helium was really expensive, quenching was bad. Right? And if you ran the magnet in a way where you caused a quench, that could be the death of the research group. And we always joke that in the Applied Superconductivity Center, there used to be a black mark system where the graduate student that had the most black marks would be the first one to be let go when the funding ran out, right? Mm-hmm. And, you know, one way to earn a black mark was to run the magnet up too high, too fast, and cause a quench.
God.
Right, and boil all the helium away.
And just to be clear to everyone, you have to cool it down with liquid helium, which is very, very expensive.
Yeah, it's about as expensive as scotch, right?
Yeah.
Right, yeah.
That's a good analogy.
Yeah, right. And now it's even more expensive.
Mm-hmm.
It's not as expensive as the superconductor as we did in the first challenge here, but but yeah, you know, quenching a magnet is really a tough thing to overcome. Mm-hmm. Now, okay, so designing a magnet where the magnet quenches or mechanically disrupts itself really has huge consequences. All the magnets in the Large Hadron Collider ring, the energy stored in them is about the same as one atomic bomb.
That's crazy.
Right? Yeah, and it's just because the current density it's just so huge, right? And so, you know, I've seen magnets that have come out that have been collapsed, you know, on themselves or twisted into hulks, you know, because some of the engineering wasn't completely worked out, right? So you talk about engineering, or you talk about catastrophes. Really, it's a catastrophe because of the you're in the unknown, and things in the unknown beyond the state of the art will happen, and the consequences of which aren't fully worked out. That's why I said unknown unknowns, right? And what you have to do. Wait, why am I in this weird ghost mode? I don't. This is really interesting.
You haven't used.
Yeah, I gained something here where I'm in this complete ghost mode. Wow. But okay, so in research where things are unknown, you can get some pretty spectacular failures, and mechanical collapse of a magnet is a thing to behold.
I mean, it's underappreciated. You're coiling this wire thousands of times. You're generating a field that has a force, and that is so much energy. Like non-generating neutrino, that's a lot of energy.
You have to think of a magnet as a pressure vessel. It's compacting magnetic flux into its middle.
Yeah.
Right?
And that's when we learn, but it comes at a cost. There's no question about that.
Yeah. And we talk about superconducting magnetic storage, or energy storage. In fact, the Applied Superconductivity Center was built 42 years ago on an experiment that sought to put the output from nuclear power plants into a magnetic
that's
field.
Interesting. Using it as like a pseudo capacitor just to store
energy. You let the power plants run flat out. Power plants don't like nuclear plants don't like to ramp up and down, right? But the size of the coil is about the size of a football stadium. Okay,
somebody did that math.
This is a monstrous field that's going to affect everybody for 100 miles away and all of that. But this was conceived, and there were various experiments developed to build the conductor and all of that. Okay, but imagine you're putting 1,000 megawatts. Or 1,000 megawatt hours of energy into something like that.
Yep.
It's easy from there to say, there's an atomic bomb floating around in all the magnets in LAC.
I mean, so one of the great things about science is we explore the limits of things, and at some point we find there's a limit. So people decided that was not a viable storage mechanism. Is that?
Yeah, actually, there's an interesting story there. Is that the project got hijacked towards Star Wars, Ronald Reagan days.
Yeah, space lasers.
Yeah, right, because they needed a quick system to dump energy in an X-ray laser. And actually, a company was formed in Middleton, Wisconsin, that makes truck bed-sized magnets that you can use to stabilize power. So it'll provide that sort of few second power brownout ride through, which is critically important for robotics. Anything that's going to reset at the power dips, right? And those were available systems. Oh, why am I cowboy?
So Tomcat, thank you for the follow. You are a 590th follower, which is pretty good. We're averaging about 11 followers per stream, which is a remarkable number. We only stream every two weeks, so it's kind of cheating. But thank you for the follow, Tomcat. If you have any questions for Lance Cooley about superconducting materials, either their application, their engineering, feel free to throw those in chat. We are happy to answer those. Yes, this discussion is very interesting. One of the things I like about the stream is I learn a lot from our guests. So, Lance, thank you for joining me.
Yeah.
I think you were a cold email, right? I just said, Lance, do you want to do some?
I think Kristen set us up.
Oh, she did. Okay, yeah. No, that's it's one of those things. Finding new guests is a bit of a challenge because you don't know who video games and wants to talk science. But Lance was kind enough to join me on the stream. Tomcat, thank you for joining us. We combine mediocre gameplay with expert science. Every 2 weeks, we have a different guest on with different expertise. It doesn't have to be mediocre.
No,
it's mostly is.
Yeah.
Very, very few times. With that said, we've had at least one speedrun top 200 times set on stream before, so we have some good gameplay going on.
I have not played Cowboy very often.
Yeah, for those
Oh,
who
that's the
familiar with
grenade. Oh,
Overwatch,
that's cool.
Lance is being forced by his daughter to play a random character every time he respawns. So it's a learning experience for everyone. But if you guys have questions, you want to mess with Lance's gameplay.
No,
feel free
Olivia,
to throw them in the
you're
chat.
getting significant points for the random
Creativity.
respawn here. I think chat does not want you to leave. Leave this mode.
Man, that's fun.
Yeah. So football stadium coil,
Yeah.
right? That did do something for the establishment of the conductor. One of the things I worked on as a graduate student was something called the proof of principle experiment, which was a, oh, look at this. I'm Genji now. Wow, I can climb walls. Should we try and climb this wall? Wait, come on. I'm climbing the wall. Come on.
Oh, it did something.
Yeah, all right.
Olivia, this is just
Yes,
cruel at some point.
I'm holding a. Oh,
there
there
it
we
is.
go. Oh, there we go. Oh, cool. Okay. Yeah. It's like my button not holding, but all right. Yeah, but so it Oh, get away from there. All right. Oh, I forgot the dash. Yeah. All right.
Sorry, Tomcat. Lance has learned a new character as of speaking this. So he'll get,
Yeah, you're gonna have to
Bear with us.
backtrack a little bit here. Yeah, fail.
oh, zero. Oh,
Good job, Olivia.
I like it. Cheers, everyone. Oh, and we're like 4 scotches or 4 whiskeys in, so you'll have to forgive us for both our science and our game.
Yeah, this was 130 proof last time.
Oh my God! What was the volume of this?
Well, that's a 375.
We're probably gonna hit the entirety of that sometime tonight.
Yeah, all good. I'm Ubering back, so whatever. Sky's the limit.
No, you made a good choice. So I'm not in Twitch to make money, but if I could make enough money to have my guest Uber home, that's what I would love to do.
Yeah.
Get them drunk enough to relax and play some games.
Yeah.
All right, we'll follow up with.
Well, finish the question.
Oh, sorry.
Yeah.
Man, what were we talking about? I completely.
Well, I got the football stadium coils and all that, but I got there, I forget why. So it was a question from Neutron,
Non-dairy neutrinos.
non-dairy neutrinos.
Oh, we were talking about mechanical force and storing energy, and that's a lot of energy to store. Maybe
Yeah.
a football field
Yep.
circle would do it.
Yeah. Yeah, so the energy scales as a square of the field and the size of the magnet. Mm-hmm. Right, and they can be destructive energies. They can be energies that mangle steel.
Yeah.
Right, and these have to be accounted for.
I'm bringing this up for seriousness of the situation, but there was a death at the mag lab at some point in the last 10 years.
that was very unfortunate, and that was, I would like to say that was an unknown because that was a block of a high pressure pathway, right? That was supposed to reduce the pressure in a system. And somehow, pressure came back from the other side, and that was before I arrived here. I arrived in 2017.
Yeah.
But
You heard about it.
the mag lab learned from that unfortunate circumstance, and double block and bleed is a standard protocol now that was put in. I kind of think it was actually in existence at that time, and there's an additional factor that went wrong. We don't like to have single point failures where people get injured or worse, right? And my understanding of the situation is that this was not one of those situations, that this was actually a rather complex failure that resulted in a death. So,
yeah, this wasn't negligence. This was just
no.
unknown.
And I think realize that sometimes 80% of the faults are actually in the way the system is set up and the way information's communicated.
Yeah.
Right.
Or the way people execute.
Yeah, in a way the hearer hears from what the speaker spoke, or right, or the the instruction was carried out on a day when the person felt under stress.
Yeah.
Right, a human condition affected the interpretation of that. Right, but national laboratories communicate their near misses and their injuries all the time, and they do this to build a strong culture. This is going to be defeat, a strong culture where things are transparent and you analyze the best of what everybody can do, and sometimes it's still not enough. Because our business is exploration of the unknown.
Yeah.
Right.
Well, I mean, I guess a follow-up to that. So there were protocol changes based on that event, but was there scientific knowledge gained from that? I mean, was there something, one of those unknowns? Do we know more now than we did then, or is it just procedural?
Yeah. Well, the procedure by which we build and specify pressurized systems completely changed, right?
Yeah.
And the review completely changed, right?
Yeah. That makes sense.
Yeah.
Sorry to bring up a sad subject, but it's, man, speaking of which, so May 24th, our guest on Ask a Scientist Gaming, he's an education professor, and he studies suicide among teenagers. Like,
what a segue.
Like, but it brings up an important point. Like, we have to, there's heavy topics we cover on this stream, right? But we're also doing it while drinking alcohol and playing video games. And so it's one of those things we have to balance all those variables. But I mean, it's a very real thing of science. Like, we progress is built on the backs of people that have died, people that have suffered, people that have gotten cancer. And it's something we can't ignore. I mean, it's there.
No, the national laboratory system is, I would say, extraordinary in its, methodology for analyzing hazards, building barriers, building protections, and so on to keep people safe.
Yeah.
And we learn from, say, the nuclear, reactor community. We learn from the air traffic controllers, where failure has an incredibly bad impact.
Yeah, well, regulations are written in blood, right? Like
exactly. If you watch any, I don't watch TikTok or anything like that, but you watch things that come across Facebook, you see the videos of the pilot declaring an emergency.
Yeah.
One of the early questions is how much fuel and how many souls on board.
That's
right.
That's true.
Yeah, and how dire is the problem?
Yep.
Right.
No, and it's something we have to weigh as scientists. And like we talked about the FDA earlier, like, is the benefit of this study worth the cost of human possibility of error?
Yeah, FDA is a very conservative by necessity.
And it has to be, right? We shouldn't be.
Exactly. Yeah. Yep.
All right, on a lighter note, kick it root down. Tell Lance I was going to crack the new ology tonight without him, but I didn't. It was presumably somebody you know.
Yeah,
kick it root. Thank you for joining us.
That's probably my neighbor across the street whom I told you about earlier.
Yeah.
And he's going to crack theology. I'm disappointed that I don't get a whack at it. And he'll tell me how
he's not going to. He didn't.
Oh, he's not?
No. Without him, but I didn't. So save it for later. So cheers, kick it root.
Holy cow. Hey, yeah, here you go, kick it root. Yeah.
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 All right. Anyone just joining us, like Kick It Root, thank you for the first time chat. Ask a Scientist Gaming, mediocre gameplay, expert science. My guest today is Lance Cooley, who's an expert at semiconducting materials and also studies alcohol production, which is a side hobby of him. But yeah.
Wherever you want to go, Olivia.
Oh, you're picking the next. We gave her a hard
she asked
time
me if I wanted to stay on Mystery Heroes. I'm like,
He did try to climb walls.
Yeah, I did try to climb walls. That's right. Yeah.
All right. So any new viewers, one of the things I like to ask as well is, what is your airplane conversation like? Like, I tell people I'm a chemist and their response is, I hated that class. So what is your reveal and how do they respond to that reveal? Like, what do you? They ask you, what do you do for a living?
I have my daughter in my headset right here.
Oh, sorry, she's talking to you.
No, and
Oh,
my wife and my daughters always said, "Dad, did you take your pill?" Because I'm the type that will walk into a bar or on an airplane
yeah,
and start engaging.
yep. Oh, so you're the one that introduces the conversation.
Maybe.
That's fair.
My daughter just said, "It's the best part about me." Oh, Olivia, love you very much.
Thank you, Olivia.
Yeah. But yeah, no, I will be able to sit in an airplane seat or at a bar stool with random strangers and strike up conversations and talk about things, but talk about, okay, what's your concern and interest in anything? Yeah, oil,
Yeah.
living.
But let's say they ask you, what do you do? Well, what's your answer for what do you? Is it a professor? Is it studying
I
materials?
answer honestly, and it usually destroys their initial opinion on me, right? Mm-hmm. But often the conversation then leaves open. Yeah, okay, I've said what I've said, but now what do you want to talk about? What's on your mind?
Oh, so what is that initial response? So you say, I'm a professor in mechanical and engineering, and I study superconducting materials.
It's
and their
usually
response
like,
is,
holy cow.
Like you must be smart, or like
Exactly. Yeah.
and then that just dies after that.
No.
exchange?
Well, I hope it doesn't die.
Well, how do
Yeah.
they respond to that? Is I guess what I'm asking is are they intrigued? Are they scared? Are they like where does that usually go? Aside from you,
I don't want to say that I'm engaging, but the evidence is that 9 times out of 10, they carry on to the next question and say, "Oh, wow, okay, let me ask you something," and go on from there.
And then they're intrigued in the topic area, and they have something. I mean, much like our stream, they have an audience that might be interested in learning more.
Okay, so I've long held that one of the core duties of scientists is to relate science to the common person, because the common person is paying for it. Damn it.
Yeah, no, that's true. Your tax
Right?
dollars at work, ladies and
Yeah,
gentlemen.
exactly. Right. So, and the common person probably has stakeholders like children, right, who they would like to be successful. And science is a pretty well-paying career, science and engineering, and you become a technical asset to a company with large income and so on, right? And and so they have a vested interest in listening to what you have to say. Okay, but I would like to, I would like to make sure that I carry out my role with a fair bit of integrity.
Yeah.
And
I mean, so you have a somewhat of an advantage in this domain because your stuff is applied. Like, this is very real. It affects people's lives after they take an MRI. So
I hope, yes, I hope I can take the technical and make it relatable, right? Because, for significant parts of my career, I had to take the technical and talk more technical, right? And it's the type of conversations where even my wife doesn't want to talk to me when I get home in the evening for dinner, right? Yeah.
Man, speaking of technical, so I'm on thesis committees for various different departments, and one of them I was just on an astrophysics committee. Sorry, I'm detouring completely, but
No,
you'd appreciate
it's
this.
entirely appropriate. It's
Magnetic field related discussion. So this student is trying to model like star formation, right? It starts out as a gas cloud with a bunch of molecules and particles, and it condenses into a star. And so one of the things they're very interested in is modeling the magnetic fields that are responsible for that collapse.
Yep.
And so one way they do it is Zeeman splitting, which is basically a magnetic field affects how hydrogen emits light. It changes the energy depending on how big the magnetic field is. The other one I learned that was very cool is that they actually use, so there's all these gas particles in the gas phase, and in the magnetic field they actually align.
Yep.
And when these particles align, not perfectly, but good enough, they polarize the light that comes off of it.
Yeah, isn't that cool?
So they actually see the flux lines based on how particles align in
Yeah.
a magnetic field in a
Yeah,
gas
yeah,
cloud.
yeah.
I'm like, holy shit.
Yeah, isn't that cool?
Isn't it badass? So they know the magnitude of the field and they know the flux lines.
Holy
of that
shit is the
field.
fun of science. You get those
Absolutely.
holy shit moments, write them down, you know?
But that's one of the reasons I love the stream is because I get to talk to experts outside my domain because those are like the moments I'm like,
Yeah.
I didn't know we knew how to do that.
That's why I like being on various review panels and so on.
Yeah.
Again, talk with experts who are outside of my domain,
Exactly.
right?
And so I mean, you're applied enough on the airplane conversation. Do you get to blow minds occasionally, or do they?
I blow minds all the time. what I don't want to do is alienate minds.
Yeah, no, absolutely. Well, it's again to cut down the ivory tower because we are not as brilliant
And
as we seem.
I credit my small town upbringing.
Oh man, that is
Yeah,
very true.
it just being, yeah.
It brings a very different
Somehow
lens.
it's inbred that you got to relate to people, and you got to relate to people on a. Who the heck is that?
No, but that's that's a non-trivial topic as well, because there was a study that came out in Nature that basically said it was something like half of all faculty are like sons and daughters of PhD chemists or PhD scientists, right? And then there's some of us that came from small town, middle of nowhere, nothing.
Yeah.
Like
Yep.
it is worth breaking down that ivory tower because it does exist. It's a very real thing.
Yep.
So,
Yep.
Tomcat, I can proudly say my daughter will graduate with her physics engineering degree in a few weeks. What's your experience in the number of women getting involved in physics?
So my daughter's going to defend her thesis on June 1st at Northwestern.
She's
so
engineering?
She is in material science.
Material science, okay.
Yep. And I am so proud that she has had a tough time in the dinosaur laden
Yeah, male-dominated
male
field.
dominated
White male-dominated
Yeah,
field.
that's right.
Physics,
you know,
math are the outstanding.
I hope I am not a dinosaur. Right, but I just graduated a female PhD.
Mm-hmm.
We are actively recruiting female PhD students because it's important, right?
Yeah.
And for many reasons that would take a lot of time to talk about. The challenge, I mean, there's a lot of challenges, but what I learned from my daughter who's in the trenches is that it's really more just the day-to-day where you're coming into a workplace where males talking about male things, and I don't have any females to talk about things from my own perspective, right? And it's like you want a set of expectations or a set of rules and whatever, but they don't exist.
Yep.
And you just feel I don't belong. I'm
it's
I'm
not
part
it's
of
not
this.
malicious. It's just like statistical.
No, it's just
like
it's kind of just a
sheer
fact
number.
of the place, an unfortunate fact of the place.
Well, sometimes it's malicious. Let's not.
Forget that. In
but-
addition, there's the
Yeah.
maliciousness. That's
Exactly.
right. Yeah.
I mean, Tomcat, it's interesting because they've done studies. I mean, if you look at the undergrad level, like biology and health sciences are at parity, male versus female. But as soon as you jump to like PhD level, that statistic sways completely. And there's a lot of discussions about, starting a family and the obligations of females versus males. It is a minefield. And I should have an expert on that at some point because it's being studied at extent.
Yep.
I think biology and like health sciences are pretty good. Chemistry is leaning that way. Physics, math, and engineering are still very heavily male dominated. And so, yeah. And each one of those females in those fields has some sexism story to describe in terms of their PhD or their job hiring or whatever.
And a good fraction of those stories are stories that are just an artifact of the situation.
Yeah.
And not an, I don't want to say not intentional, but
I mean, there's a certain generation
it's
of
there.
colleague that like doesn't even
burden
know they're
that's there.
wrong.
Yeah, exactly. I still like the word dinosaur, right? Because a dinosaur didn't know it was going to become extinct, but it did.
Yeah.
Right?
No, it's true, and that's one of those things you talk about progress in science being made at the death of senior colleagues. The same thing is true for the social dynamic in the sciences.
Yeah.
And so we can see it in the younger generation. We're all conscientious. We're all aware. Well, I won't say all of us, but I mean, I think the dynamic is definitely changing. And over the next 20 years, when the boomer generation passes away, it'll be a very different landscape than it was even now. So I don't know. We'll see. But Tomcat, congratulations to your daughter. Physics to engineering.
Yeah.
That's interesting. Physics
Yeah,
and engineering.
and
or is
stay
that
there and be there for her. Mm-hmm. Right? Champions are very important.
No, and support network is absolutely necessary. And it's I want to say it's getting better, but also I have the lens of a 6'2" white male with a booming voice. I have a very different lens than a female does going into that circumstance. So, yeah. Serious topic. Wow, we're like 4 whiskeys in.
We're like 3 serious topics with 4 whiskeys in, right?
Man, but this is one of the things I love about Ask a Scientist is we journey through many different topics over time.
Hell yeah.
And we're 2 hours in right now. I don't know if you were looking at the time.
Oh, jeez. Doesn't feel like that.
No, it doesn't. Wait, it feels longer or it feels shorter?
No, it feels shorter. I mean, Olivia and I play often, and the time goes by fast.
Yeah.
I just got resurrected like for the 18th time by my daughter.
Well, I have to say it's amazing that like this is you maintaining a conversation with your daughter via video games. And so one of the things that opened my mind, and one of our colleagues in biology said this, it was like there was a turning point in his relationship with his kids when he was no longer the driver for them. So when they turned 16, they had their own car, and like that driving was a moment for them to interact and communicate and things like that. And then that disappeared, and you've managed to fill that gap with video games, which is pretty.
Yeah, I think in the case of Olivia, our special bond formed around metal. Heavy metal music. My introducing her to Slipknot.
Awesome.
Right, and going to Warped Tour back in 2007 or 2006.
Oh my God, in person experiencing that.
She's speaking to me now. When did we go to Warped Tour the first time?
And how old was she?
It's earlier than that, Olivia. Olivia, I'm not gonna speak her age, but she's out of her 20s.
Yeah. That's pretty intense. Slipknot.
Olivia, how old were you when the guy from was it Thursday swung the microphone around, got it in the chops, and his nose was bloody? Yeah.
Oh man.
I think that was like 2006 or 2007. It wasn't that long ago.
Ladies and gentlemen, we've emptied the bottle. You said this was 375 milliliters. Yes, it is.
Yeah.
Oh, mission accomplished, assuming we drink these glasses.
Hell yeah.
All right. Anyone, if it's been 2 hours, a little over 2 hours on stream. Anyone just joining us, Ask Science Gaming, Mediocre Gameplay, Expert Science. Our guest today is Dr. Lance Cooley, who's an expert in semiconducting materials. He's an engineer.
Semiconducting.
God damn it. Superconducting.
15 points for me.
Superconducting materials. I apologize, ladies and gentlemen.
Oh, that's not an apology. It's just points for me.
He works in superconducting materials, particularly the engineering and physics behind those and how they are applied in various different ways. He's the director of Applied Superconductivity. So if you have any questions, throw them in chat. Oh, yeah. Metal Death Clock.
Libby, I got
soon.
An endorsement. Was that competitive or?
What does an endorsement mean in this?
I got an endorsement. Yeah. Ooh. I'm like,
you got an achievement here?
Wow. So wait, new baby metal.
Non-dairy neutrino. I stay in touch with my friends across mountains in different states.
I have instructions to tell non-dairy neutrino that. What about metal?
I'm excited for Baby Metal Death Clock Tour.
About the Baby Metal Death Clock Tour. Yes, Olivia? You're in?
Death Clock, isn't that...
You're excited for it. Yeah, well
isn't that Metalocalypse, the Cartoon Network? Isn't that Death Clock, or is that a separate group?
Well, I mean, I don't know. I get my information from my daughter about this stuff. Death Clock tour. Let's see.
yeah.
I think that the recent tour. So we didn't. Oh yeah, look at that.
Death Clock. It's from the cartoon. Yeah, the Cartoon Network Metalocalypse.
Wow.
Yeah, I'm
Oh, we
surprised I
know
knew
Death
that.
Clock though. I know Death Clock the band.
Yeah.
Yeah. Oh, they're headlining for Metalocalypse.
No, they're from the TV
fictional-
series.
yeah.
Metalocalypse. That's
Yeah.
Death Clock. Yeah.
Oh, man. But wait. No, but they're headlining Metalocalypse. Oh.
Also, no, Metalocalypse is the show. Death Clock is the band. So I don't know how these guys are touring, but they are.
Yeah,
It's a cartoon.
little babies going, you know. Shredding.
That's awesome. So non-dairy neutrino. We've tapped on many of your interests, including alcohol, heavy metal, and video gaming, and physics and engineering.
So the last
successful
time I went out to a tour with Olivia was on Jones Beach, I think, in New York. There's a festival. Did we see Typo Negative? Who did we see there?
Oh, typo negative. That's fun.
Yeah, well, we saw AFI. I know that. We saw AFI somewhere in Chelsea, but we also saw, oh, for crying out loud, Five Finger Death Punch, and In This Moment, that's who it was. And SLA Dying, they were on the stage as well.
Unrelated, we got to do some predictions. We're running out of time because we've been drinking and talking too much. What do you want to do next?
Oh, I don't know. Hey, go wherever you want to go. Yeah, we can do that one.
All right. Let's do this one.
What did I pick, Olivia? Here we go.
This is one of the ones I had to edit for character count. What a weird restriction to put on a Twitch prediction. All right, ladies and gentlemen, we're going to put a prediction up there right now. You guys are going to be asked a science question. The question is, the first superconducting magnets, was that after humans on the moon or before humans on the moon? Note that was 1969. And so the question is, when were the first superconducting magnets discovered, generated, measured? Was that before 1969 or after 1969, before we landed on the moon or after? Throw your predictions in there now. So note, you guys have standard internet units. If you're not following us, click the follow button. Even if you're never going to watch us on Twitch again, it helps with our visibility and number of people watching and things like that. Click the follow button. Use your 300 standard internet units to gamble on this question.
Bet big, go for it.
Man, I love these questions that have like referential human accomplishments, like superconductors versus space travel. They're not directly related, but like the timeline of human achievements, like learning that Darwin and like Beethoven were alive at the same time, is a weird thing to understand, right? And so this is kind of in that context with science questions. Tomcat, do not put your answer in chat whether you think you're right or not. Instead, click the predict button, do your gambling of your internet points depending on how confident you are, which is fun about Twitch predictions. If you're really confident, you can bet more points on it and get a better return on investment. So feel free to throw your predictions in the question right now. But yeah. Non-dairy neutrino. Follow up. It's actually interesting how they do it. So going back to Metalocalypse and Death Clock, they have Death Clock on the big projector, and the live band plays on the stage in the dark. So you're seeing Death Clock and hearing the musicians. So they take the actual musicians from the cartoon, they play the music, but the band is up there. That's similar to the Gorillaz used to do that, right? It was a compilation of musicians, and they had a basically cartoon surrogate for their performance. All right, so it's closed. Lance, what's the answer? First superconducting magnets before or after 1969?
So Kutzler, 1961.
1961, so before humans on the moon, we had our first superconductors. And that's a breathtaking...
Westinghouse and I forget who else, not RCA, could be RCA, but Bell Labs. But they got into a competition over magnets.
Yeah. Who can make the better superconductor?
Well, the appearance of wires happened.
Yeah.
With high field superconductors packed into them. And for the first time, the wires made magnets that reached a field that was predicted in 1913 by Camerlinganus.
1913.
Yeah,
I love
so
that.
Camerlinganus, discoverer of superconductivity, immediately thought about high field magnets and the energy that might be saved in building such a thing with resistance-free wires.
I mean, so
Right.
what's the theoretical foundation of that? They were just thinking like maybe this is possible at the extent of our limits, or they thought about Cooper pairs, or what was the theory?
No, Cooper was 1957. Cooper
That was much
pairs.
later.
Right, yeah.
Later. So how did they even conceptualize
So
superconductivity?
Camerlinganus just looked at the fact that you have to pay a penalty for cooling a resistive winding.
And that was
right?
it.
And you might need so much power to cool an electromagnet that it would take the consumption of, I think he said, a cruiser, a naval cruiser, to build a 10 Tesla magnet, right? If you could figure out how to cool the windings of that thing. And this actually is what MagLab does. MagLab is brute force. MagLab builds magnets that are cooled by I don't know if it's 1,000 or 200 or 2,000 or whatever gallons per minute of deionized water flowing through a high conductivity, high strength copper alloy, right? So Camerlinganus knew this at the time and said, we have an opportunity to make really high field magnets because we don't have to cool the damn things. Okay? But he never got there because it turned out that they didn't know about things like critical field and didn't know about other factors that presently, underpin magnet technology, right? But what is recognized is that he could, you can take and trade the different energies. So, I'm concentrating on killing this.
It gets hard late in the night.
Yeah, that's right. But trading refrigeration power for magnetic field has always been an engineering variable that we've been working with, right? Current density helps, and critical field helps, and that's what the modern superconductors have that enable them to get there without building up tremendous losses at lower fields.
So you have to forgive me for not knowing. I mean, were there Nobel Prizes for theory of superconductivity and then demonstration of it?
Yeah.
There were for both the theory and the
Bardeen
demonstration.
is one of the only double Nobel, I think he's the only double Nobel Prize winner, right, for the transistor and for the theory of superconductivity.
So follow up on our prediction timeline. Non-dairy neutrino, that's truly unfathomable. I was going off the fact that we didn't make Bose-Einstein condensate until in the 1990s. Yeah, which is true, but we got superconductors in the 1960s, which is pretty incredible.
Yeah.
So before humans landed on the moon, note that us landing on the moon was the equivalent computational power of a TI-85 calculator, which is another unfathomable feat when you think about it.
Yeah.
All right.
Calculating Euclidean.
Yeah, exactly, with
Yeah.
that type of computational power.
Yeah.
All right.
I really like that movie. The women who worked at NASA and provided
Oh yeah, Hidden Figures.
hidden figures.
Yep.
Yeah.
And that got it right.
But the part of the movie where we got to go back to old school, got to go back to Euclidean, or Euclid's method, right?
All right, non-dairy neutrino. On the other hand, I equals VR has a singularity at R equals 0. I remember it in my introductory E&M electromagnetics course, and my professor mentioned things get weird when you get really low resistance and temperature, but you do get to R equals 0. And that's as much as I know about superconductors. I mean, that's a summary of science as a whole. Anytime anything approaches zero or infinity, the rules break, and we got to figure out better
Right.
rules.
So he's taken us back to, the turn of the century when we were realizing that electrons were mobile, and going back to what's the origin of electrical conductivity or resistivity? What are the things that impede it? How do we make a really good conductor? Why is copper better than iron? Right? And so there were ideas that what Camerlinganus did, he was associated with that problem. But as temperature, so temperature is vibrations of the atomic nuclei in a crystal lattice, right? So the things are moving around, and they're bumping into the electrons. The electrons are ending up getting scattered by the thermal vibrations. Well, as you take away the thermal vibrations, the question is, what happens? Does the electrical conductivity just go up to infinity, or the resistance go to zero, or does it do something else? And quantum mechanics was just being born, and in the something else, there's thoughts that the electrons might get stuck. They might not be able to extend across multiple atoms. I just died. But anyways, so does resistance go to zero when temperature goes to zero? Does resistance blow up, or does it do something else? Camerlinganus distilled mercury to make an extremely pure metal, something that could not have been made in any other way, and he had access to liquid helium, so he could address this question of what happens when you drive things towards temperature equals zero in a system where there should be no other sources of electron scattering. And he didn't expect the result. The result was that resistance dropped to zero at about 4.2 Kelvin. It didn't go to zero at zero. It went to zero at a higher temperature. And a little bit later on, 2 years later on, there was an experiment to test for persistence where there was maybe a short circuit loop of wire that decayed extremely slowly. There's no measurable decay in the current going around that loop. And that proved it was sort of perpetual motion, resistance free.
All right, we have about 7 minutes before we start playing NARC. You got one more
NARC?
round in you?
Okay.
So Lance learned about NARC tonight. I didn't give him a heads up on this at all.
This is going to be
you
a
have
big
one more
fail.
round in you, and we'll do.
All right, one more round, Olivia.
All right, we'll speed run some questions because we got to catch up on a bunch of them. Non-Dairy Neutrino wants to know, how cold do superconductors have to be now? So standard superconductor, what temperature do you need?
Most applications are liquid helium, 4.2 Kelvin, minus 452 Fahrenheit. Applications are blossoming at 20 Kelvin and 77 Kelvin, which I think is minus 196 centigrade, so it'd be about...
Good
boy,
luck.
I'm converting quickly.
Fahrenheit.
I don't know what Fahrenheit
What is it in
is.
American freedom units?
That's right.
77K is fine. That's
Yep.
liquid nitrogen.
Yep.
Somebody else can Google that or
Things
GPT
get
chat.
better as you get colder.
Yep.
The industry that has been booming is the industry with cryo refrigerators, cryo coolers. Right?
All right, Huggy Beer, welcome back to the stream. Thank you. It's always a pleasure to have you. The question is, could quantum locking work with Earth's magnetic field?
Quantum locking.
I don't know what quantum locking is. Do you know what that is?
Yeah, I'd like to have that explained. So quantum locking has to do with getting all the states in various quantum systems be connected together into a single quantum phase, right? Or it's not a collapse, but it has to do, I think, with
So here's
a macroscopic quantum state based on, of microscopic objects.
So here's the two-sentence definition from Hacker Noon. I don't know what that is, but quantum locking occurs when a superconductor becomes trapped within a magnetic field. When this happens, the superconductor will be locked in space and will not move without an outside force. Now, this is possible due to the Meissner effect.
Well, okay, so I would call that flux pinning. So
interesting. That's
a
fun,
superconductor, right? So the magnetic field lines are quantum objects inside a superconductor. Right? They're loops of current with cores. We call them fluxons. So they behave like individual quantum particles, right? And when those particles interact with defects in the superconductor, and some of these defects can be engineered and planned, some can be random, but when they interact with defects, they get stuck. Mm-hmm. The engineering of superconductors to have high currents from magnets intentionally puts in second phases and other junk, right, to enforce this flux pinning and create a high current density and a lot of current for the magnet. All right. So, but you can't make a perfect material. These defects are always present. And in maglev experiments, a human levitator, that type of experiment, there's natural flux pinning in any material. Okay. So now, quantum locking, so the magnetic field gets stuck on these materials and can't move, and gets locked unless a very large force is applied. So there's a force balance, say, in a magnet between the Lorentz force of a system of currents and the pinning force due to the interaction of these field lines with the material defects. Oh, I got killed there by an atomic bomb again. Don't about it. Yeah.
And the kill cam.
So to do, maybe you've seen the human levitator experiment. To do that experiment, what you want is enough circulating current to oppose the magnetic field of the magnet that the person is standing on, but also enough flux pinning to not let the magnetic field lines move around. And it kind of keeps the magnet situated into a fixed position above the superconductor. Maybe that I'm looking at your Wikipedia definition. That's
no worries.
That's what quantum locking. I think is, but it's really flux pinning.
Yeah. No, non-Darwinian neutrinos followed up. Which is a better name, quantum locking or flux pinning? So you pinpointed it based on which is awesome.
Flux pinning is the key to superconducting technology. The more pinning, the higher the current density is.
All right, Huggy Beer. Second question: space is cold. Can we make superconductors in space easily? Is it better if we fly a superconductor out in space and have them free float amongst the cold? What is space, like 2 Kelvin something?
Yeah, 3 Kelvin, something
3
like
Kelvin,
that. Yeah, superconductors love space. Mm-hmm. NASA wants lots of superconductors, for things like shielding of particles that might damage astronauts.
Yeah. Right? Make your own magnetic field, your own.
Yep. And magnetic fields. That's right. Just like the Earth's magnetic field shields all of us from harmful and damaging particles.
I mean, is that I haven't even thought about that. That's an explored area. They want to induce a field in the space shuttles.
Well, they want to put a large magnetic field coil around it, around a Mars mission capsule. Yeah. Absolutely.
And that's, right? Wow.
And you got to keep your astronauts protected from cosmic rays. Cosmic rays are actually protons of very high energy flying through space. Right.
And so the problem with space is there's not a lot of heat conductivity, right? So seeping that heat away is a hard problem. How are they? I mean, theoretically, it's awesome to have it in space because space is cold, but there's a conductivity issue, a thermal conductivity issue, presumably.
Well, okay, so then there's a irradiation issue. So if you soak up the sun's warmth, the sun's radiation, the material will get warm.
So you need a transparent superconductor.
Yeah, well you need to understand thermal conduction and thermal radiation and situate the superconductor properly. Right? There's no
All right.
convection in it.
So we're at 10:30. Is it time? Should we switch
Is it
to
time?
NARC? I think it is.
All right. So, hey, Olivia, it's time.
Olivia, it's been a pleasure. Thank you for
It's been a
joining
pleasure.
us.
Yeah, we're bailing out of Overwatch here. It's time for me to do crazy things.
But now you can watch your dad play NARC for the first time ever, and he's going to speed run it, and he's going to be timed versus his colleagues. But
Okay.
he has
See you
infinite
later,
lives,
Olivia.
infinite rockets, infinite bullets, so he's
GG.
going to be fine.
Bye.
All right, ladies and gentlemen, as we do with every single stream, Lance has kindly agreed to transition to a game called NARC. Lance, if you're not aware, this is a bargain bin game for the Nintendo Entertainment System.
I have no idea what this
I
is.
played it once on stream, and it started as a joke, but after that, I made every single guest play it. So you're going to be playing on the original Nintendo
Oh, good.
Entertainment System. And beyond that, we're going to have a speedrun timer. Do you want to see the timer, or do you not want to see the timer?
I don't want to. Well, okay, put the time. All right, whatever.
All right, ladies and gentlemen, it is time for us to close our night with NARC. So press start. So the goal of this game is you're going to walk right as fast as you can, and that is basically the extent of it. So this is a bargain bin game for the NES. So remember Blockbuster? This was the $5 game in the bin as you walk out of the store because nobody wanted it. You're going to walk right and you're going to try to go through doors. And so what's something they did in this game that was clever is they took 2 buttons and they turned it into 4. So if you hold A, you shoot bullets. If you tap A, you shoot rockets. If you hold B, you squat. If you tap B, you run. And so there's no advantage in killing anyone. You want to go through the doors at the end of every single level.
Right.
And so you have infinite lives, infinite rockets, infinite bullets, and you are trying to beat this as fast as you can. So
Well, so my first instinct is to start jumping because you go faster in Overwatch.
yep, every
by
single
jumping.
time you get shot by 7 bullets, you are slowed by a second.
Oh, I got one of these.
Yep,
So
go
what
through
do
the
those
doors.
do?
Go through the doors.
Come on, go through the door. Through the
Oh,
door.
hit boxes.
Oh man.
That cost
I got
him.
the
That was
dogs all
1.75
ate on
seconds.
me,
So
yeah.
press up. There you go. Go right. Find a key card. Find a door. Yes, non-dairy live split is what we use. It's an amateur version because we only have 1 time slot, but we should do splits on this at some point. All right. Non-dairy, you've been on the stream many times. You didn't know there was a live timer in the top right corner. So we've
Fine,
had
oh.
30 or so guests. We know the times. So you're competing against your colleagues across biology, psychology, sociology, physics, oceanography, whatever it is. You are competing with them now. No pressure. All right.
Oh, I'm not concerned. I'm not
No, it's just walk right. as
bottom
fast as you
25% here. Yeah.
can. You'll be fine.
Oh, let's kill this guy.
No, there's no advantage in killing anyone but the end bosses and a few people that need to drop key cards. So keep going right as soon as you can. Next time we have you on, you'll be aware this is happening, so it'll be much easier.
Man,
But right
look at
now,
this. I've got 2 sticks already.
oh yeah, no, they're shooting you with heroin needles. By the way,
Yeah, oh really? Yeah,
So this
good.
is a game written. and
That's great.
coded-
Apple II game, Leisure Suit Larry and Land of Lounge Lizards.
Leisure Suit Larry.
Yeah,
If we get sick of NARC, that's the time.
that's the time.
Yeah.
Oh jeez. Oh, I'm dead again. Oh, man.
Oh, non-dairy neutrino. I'm assuming you're sharing the link for speedrun.com, which is pretty spectacular. Here, I'll share the link if you guys want to see it. There it is, right there. My favorite part of that
Wait,
non-dairy
it says
neutrino
exit. I can't
is
get
that.
through the exit.
So you got to shoot the guys wearing black with bullets, and one of them is going to drop a black card. So if you hold A while
Oh,
shooting the guys
wow.
in black, yeah. So this is a random number generator moment. So hold the shoot button, bullet button, A button,
Yeah.
and you got to shoot the guys, not the rockets, the bullets. So hold that button longer. There you go.
Oh, there it is.
Yep. One of them is going to drop a blue card.
Okay, now I gotta get the card. How do I pick up the card? I gotta walk on it? There we go.
So that wasn't the card. That was money because
Oh,
drug dealers
doggone.
drop money. So you have to shoot them again with bullets.
Oh, now I'm dead.
And one of them will drop a blue card.
Well, look, they got fermenters here. Well, what's up with this? They're making whiskey.
This is a chemistry lab. So that is, I don't remember
Yeah.
his name, but he's a chemist that makes heroin. So yes, non-dairy neutrino speedrun.com. You'll note that Vestib is the moderator for NARC. That is me, actually. So I'm the one that gatekeeps the speedrun.com records on NARC because the previous record holder didn't pay attention anymore. All right, we're going to catch up on some questions while this is going on.
Oh boy.
Huggy Beer, slightly off topic. If protons are positively charged and electrons are negatively charged, why aren't they pulled towards each other?
Well, because electrons are flying around like orbiting planets.
You'll say that's a chemistry question.
Yeah. So that's the Bohr model of the atom, sort of circa 1900. Is that electrons are in orbits, like the moon is in an orbit. But actually, there is a quantum mechanical. Oh, did I get that? No, I didn't.
No, it's going to be blue. It'll be a blue card. So kill all these guys.
There is a quantum mechanical probability that the electron might actually pass through the nucleus and through a proton. But yeah, they're flying around like planets.
No, Huggy Beer, one of the fundamental things that you've asked, and this was early 1900s in chemistry, is like, we knew electrons were negative when we knew protons were positive, and so that's where the Bohr model came from, that the electron was orbiting around the center. But quantum mechanics was really a breakthrough in progress and knowledge on that, because it basically said the electron can orbit, but it can only orbit at certain levels. It can't go to the center, it can't go to certain sub areas. That's where literally the foundation of quantum mechanics came from. This idea of quanta, or only certain levels could be occupied during that.
Right, the electron can only go certain places. That's right.
And so it's one of these really fun, naive questions, but it's literally the foundation of quantum mechanics that said we can't answer this with classical physics. We need something new to describe
Right.
this.
Oh, shoot dogs.
So you press. Oh, there's the blue card.
There it is.
Perfect. Yeah, so that's one of the most annoying parts of the speedrun, because that's called RNG. I don't know if you're familiar with speedrunning at all, but speedrunning is trying to beat these games as fast as you can. And there's some things that are like same every single time. There's some things called RNG, which are random number generated, which whatever the code says, when that blue card drops, I have no idea. And so I know way too much about this game, but you're going to walk right and go to a car as fast.
That?
No, you don't want anything. You just want to walk right. There's no advantage in killing or collecting anything for the most part. All right. As the kids say, electrons go burr. Absolutely, that is true. Matt isn't a robot. Welcome back to the stream. My two goals: 1, get good at NARC, and 2, get mega smart super fast. Matt isn't a robot. Those are noble goals. If you want to get good at NARC, it turns out there's a speedrun tutorial.
Okay, I can use the car?
Yes, you can jump in it. So you.
Well,
press
I'm past it now.
you can go back to it if you want. It's totally up to you.
Oh, really?
All right. Let me share this right now. All right. Matt isn't a robot. Here it is. That's your 30-minute speedrun tutorial. If you follow the instructions in that video, you will get a sub 10-minute speedrun time. You get sub 9:30 and be a top 5 time. If you played NARC for like a week playing by those rules, you are going to beat the speedrun time. And submit those and I will approve them as a record speedrun time. So feel free to do so. Huggy Beer, valence electron levels, right? So there's something called... so you have the two different subcategories. You have valence electrons, and then you have like these occupied electrons. It's weird. Valence electrons are talking about the orbitals that are at the highest level. Those are the ones that react, and that's what we talk about a lot in chemistry. In terms of if you're going to make or break bonds, that's the electrons that do it, the valence electrons. The core electrons, they kind of sit there unless you hit. So you tap B and you can jump over that wall. There you go. Physics be damned. Sorry,
Video game physics, so that's good.
But Matt isn't a robot. I'm 100% serious. I'm the moderator of the NARC speedrun channel. So yeah, feel free. Something screening. Screening of electron charges. Man, we're diving into chemistry. General Chemistry 1, by the way. That's one thing I want to emphasize to people, and the reason I can talk to any colleague of any discipline is that You know, we draw lines when we teach classes, but nature does not give a shit about any of that, right? Like there's no physics or biology or chemistry in nature. It just has phenomena that exist, and we've compartmentalized them arbitrarily as humans. And none of those compartments actually have any influence on our knowledge. So keep that in mind when you're deciding between different disciplines, because there is no boundary. All right, what other questions do I need to ask you?
I don't know. How do I get away from a dog?
Ooh, this is a fun one.
Oh,
what
my
is
gosh.
the Earth is flat or anti-vax equivalent in your field?
What is the Earth is flat equivalent?
I have one suggestion: magnetic bracelets to heal people.
Yeah,
Have you
that's a
come
good
across
one.
that? So go down to
That's
car,
a good
press
one.
B,
Yeah, I got in. I got in before.
stay at the bottom. Maybe press down a little and press B.
Come on, get in the car. Get in the car. Get in.
You are dealing with, there we
There
go.
you go.
So stay at the bottom. This will get you pretty far, but you're going to run into the bombs at some point. Here we go. So jump over the wall, keep walking right. I mean, so what is the anti-vax flat earth equivalent in your field? Magnetic bracelets for healing, that is one thing I can envision. Is there something else?
I kind of think the pipe dream of room temperature superconductivity is a distractor,
Oh, that's interesting.
right? So superconductors are forever going to need a coolant because the applications are always going to be driving flux in and out of them, ramping magnets up and magnets down and so on,
So,
right?
So if you get in that car and stay on the bottom, you'll be good till the end.
Okay, so for that reason, we got to get to the business of getting things. Oh, look at that exit.
door.
So I got to
Yep.
go here,
Yep.
right? But for that reason, if you get the room temperature superconductor, how do you make it practical? How do you make it in kilometer lengths that people can buy and companies can buy for cheap? And so,
I mean, so from your perspective, is it the temperature or the pressure that matters more? I mean, it sounds like the pressure is the more reasonable. If you're going to coil something, it has to be at ambient temperature.
ambient pressure. Yeah. I mean, a superconductor under pressure is a weird superconductor. We don't work with those, right? But it's also got to be a superconductor that's friendly to making in long lengths by technologies we know about.
Mm-hmm.
Copper wire drawing. Right.
Oh man, this is a fun one. Matt isn't a robot. In The Mandalorian, they've referenced magnets at one point. It made me wonder if magnets would naturally work the same on other planets. How much does the gravity impact magnetic fields?
None. None.
Short
right?
answer, Matt, is Mandalorian is legit.
Yeah, that's right. So one of the fun things about the Higgs boson, is that where the energy of the Higgs boson came in is that, go. It's addressing a question of how many universes are there? Are we in a multiverse or a single verse? And if you watch the Netflix movie Particle Fever,
I've not seen that. That's curious.
yeah. One of the conundrums about the energy of the Higgs boson is it's right in a weird place. It makes available the opportunities of having
So
not just
sorry to interrupt, but you're going to have to shoot these Rambo guys with bullets, and one of them is going to drop a green card. So go that way. Shoot the green guys with bullets instead of rockets.
Yeah, okay.
And one will drop a card. I apologize because we're on a train of thought and I'm not going to remember it.
Yeah.
But the rules of the game mandate a green card has to drop. Oh, there it is. Perfect. Grab that card.
Yeah, I'm trying to, yeah.
Yep. And then go through the door. Sorry, I completely forgot the question.
Yeah, this is one of the fun. There we go. One of the fun things about particle physics is that where the Higgs boson came out is kind of a maddening puzzle for everybody.
Mm-hmm.
And all right, there's not a single universe. It doesn't fit with the theory, with the standard model. But, the number of alternative universes where physics has different constants and magnetic fields might react with physics in weird ways, right? And physics is different, is still in play. Okay, so what does that mean? Does it mean we can create anti-gravity by connecting to another universe? Does it mean that we can do other weird things? I don't know, but this is what's being contemplated, say, in the context of the future circular collider at CERN. Right? Physics beyond the standard model.
I mean, well, one thing I'll say on this, having sat on several astrophysics committee members, is that like there are emission lines from hydrogen and carbon and iron and whatever it is, and they always stay true. Whether something's like 60 million light years away, it's always consistent. And so within our universe, as far as we know, I think the rules are, I mean, generally they're very similar. So you're going to go all the way to the right in this case. And so
I thought I could shortcut on you.
Matt is a robot. You've summed up Ask a Scientist Gaming perfectly. It's so nice to have a channel where I can easily ask these 2 a.m. questions. So what you don't know, Matt, is a robot, is that every single question that is asked on Twitch stream, I just assume you guys are adding a man at the end like you're stoned. Like, why does an electron and a proton collide, man? So, yes, that's what we're here for, and that's what we have fun with. So, yeah, ask these questions no matter how absurd you think they are. We are happy to answer them because we are... What are we, 4 drinks in right now?
Yeah, 4 or 5. Something like that. Yeah.
There's no question I'm going to be hungover tomorrow when trying to address my scientific professional career.
Where am I going from here?
To the right. Just keep going to the right. You'll find a door. Go to that door. You have that card already.
Oh. Wow.
Or as Q in Star Trek, the next generation suggests just change the gravitational constant of the universe.
Yeah, if we could do that, right?
Keep going right.
Yeah.
That's a non-trivial ask, right?
But okay, so go back a century and 20 years, right? Back to the dawn of quantum mechanics. So we're searching for energy systems. And why is the particle accelerate in the Department of Energy? Right? It's because we're searching for energy. Energy is the number one thing, number one challenge. If you have enough energy, you fix all the other problems.
Yep. Unlimited energy solves all.
Yeah, that's right. Okay, so, the structure of the atom appears, and it's got implications for what...
So sorry to intervene. If you want to shoot the dogs, press both buttons, and it'll squat and shoot. So hold them both down. Or rockets. That'll do it. There you go. Little dog.
Wow.
Sorry.
Little dog. Yeah.
Anyway, I'm sorry I interrupted you.
Yeah.
Okay, I'm going to interrupt again because right now there's going to be a guy in a wheelchair that comes up and you have to shoot him with the rockets.
Oh, interesting. All right.
So the rockets are tapping A.
Gold say, ooh, I got to get this one.
So you have to shoot the guy in the wheelchair and he's going to drop a gold card and then you can go through that door. I use energy almost every day, man. That's one thing that intrigues me about all the sciences. It really comes down to energy bookkeeping. And so whether you're doing semiconducting,
exactly.
superconducting particle physics, or you're doing like evolutionary biology, it is really thermodynamic bookkeeping. Where's the energy allocated and how efficiently is it transferred? Which is breathtaking to me that it's simplified in such a way.
I gotta get the wheelchair guy, right?
Yep.
Oh, die.
Non-dairy neutrino. I always like the saying, energy is the currency of the universe.
Yeah.
I mean, that... So there's a biology professor, Greg Erickson. He doesn't play video games, so I've never had him on stream. But he wants to look at...
I play golf with Greg.
What's that?
I play golf with Greg.
No, do you really? You should convince him to do the stream, because he said no.
He'd be good.
No, he'd be a spectacular, but he just doesn't video games, so that's a challenge, obviously.
Right, well, okay.
But
we'll have to train him.
He's looking at biology from the perspective of thermodynamic bookkeeping, because evolutionary biology is like, if you save a certain amount of energetics via one mutation, all of a sudden you make 2 more kids. And that's what it is, essentially, when you break it down by those means. Ask a Scientist Golfing coming soon.
Scientist golf league.
Yeah. No, we just need a GoPro camera on Lance while he goes golfing with Greg Erickson.
Yeah. It's Harvey Hacker Golf. Yeah.
Mediocre golf, expert science.
Greg is great. Greg gets the most use out of a putter that I've ever seen. Putter from 90 yards, he'll do it.
I can't attest to his golf game, but he's spectacular when we did in-person Ask a Scientist, because, like, fossils are a very tangible thing that most people know, right? So, yeah.
Oh, man, come on, die.
Anyone heard the comedy song "What's the Meaning of Stonehenge" by Ylvis? Is that the person that did the what does the fox say song? I think that's the same person. It's a very stoner notion. Oh man, I don't know, but I have to look this up.
Come on, it says safe. All right, I need to get to that safe.
What's the meaning of Stonehenge? I'm not sober enough to deal with these questions. Lance, how are you doing?
5,000-year-old druids?
Yeah. What's the meaning of Stonehenge is a song.
By Spinal Tap?
All right, we have about 10 minutes left in the stream. If anyone has any... Sorry, I'm burping at this point. If anyone has suggestions of people we should raid, throw them in chat, because we're going to raid sometime in the next 9 minutes.
Uh-oh. What is this? Mr. Big.
What's the meaning of Stonehenge? That's the same group. I put that in Google and it gives me very diverse answers. So I'm going to look that song up at some point.
Yeah. Spinal Tap.
Interesting. That reminds me of the only good answer to what is the meaning / purpose of life to increase entropy. Do you guys talk about entropy in your domain?
Not really.
I mean, it's an intriguing concept. Oh, sorry. So I got to coach you through this, boss. So you're going to go up to the top of the screen, get away from him, jump, tap B, it'll get you away. So go to the very top. He can't hit you. Press up. And you're going to go to the right. And basically, you're going to turn back, press jump, and on the way down, shoot rockets. And it'll shoot him in the hat. And that'll reveal his next stage. So stop there, turn around. Just stand there, tap B, and then tap A. On the way down, tap A. No, I'm sorry. Lance, I apologize for you playing this game, but that's what you're going to do. Go to the right, turn around, tap B, tap A on the way down. And you're going to shoot a rocket into his hat, and that's how you beat the first stage of this boss. Oh man, I really hope I'm sober enough to remember tomorrow I need to look up what's the meaning of Stonehenge song. All right, we have about 10 minutes left, ladies and gentlemen. If you have questions for Lance Cooley, he's the director of the Applied Superconductivity Center.
Definitely not setting a record here.
Despite the gameplay, he is an expert in semiconducting materials. So we got superconducting. God damn it.
That's 3 for me.
It's getting worse over the night. I warned you about this too ahead of time. All right, superconducting materials. If you guys have questions, ask them, Lance, right now. If you have people's suggestions that we should raid on the stream, throw them in as well, because we're happy to visit other scientists, other educational streamers, while Lance tries to beat NARC, which is a terrible bargain bin game for the NES. I apologize, you have to do this. So stop, turn back, press B. Yeah, you don't want to walk towards him. So get a good distance, turn back, stop moving, press B, and then tap A on the way down. So you have 7 frames to tap B to get a jump. And that's 7/60ths of a second.
Really?
Lance, the reason I know a lot about this game is I'm the former world record holder in the speed run of this game.
Oh, really?
And it's because it started out as a joke on Ask a Scientist Gaming, but they challenged me to play this game as fast as I can. So I ended up figuring out a glitch in the game to do a speed run. Non-dairy neutrinos. Super semi or semi-super? Semi-superconducting?
Oh,
is that a
I
thing?
didn't get that. All right, let's try that again. All right, so you get over
Can I
here.
post a link for the song? Huggy
You
Beer,
turn
if you
back,
send
you
me a link to the
jump.
song, actually, I can search for it right now. I'm going to find this because other people need to know.
I'm firing too soon.
What's the name of this song? What's the meaning of Stonehenge? I will find it, and it's by, I don't know how to pronounce that
Spinal
name.
Tap.
It's Yildiz. You may have won the getting Ken drunk on stream game. Bringing your own aged whiskey was a wise choice.
Okay, come on. Jump. How do we...
Song.
All right, so here you go. Jump.
Blixie, what
Bam,
is that?
bam.
Actually, Huggy Beer, if you whisper me right now, I can post the link for you. We have it restricted so people don't spam the stream, but if you can whisper me directly, I will share that link.
I'm punching. I'm not firing rockets.
Yeah, so maybe press less hard on that button. So stop moving, turn back, jump a little earlier on the rocket fire.
Well, that was a gunfire. Wasn't a rocket. All right, so here we go.
Non-dairy neutrino. A while back, I had this whiskey that was aged in rum barrels, or maybe it was the other way around, but it was really good.
Yeah, no, of course. Yeah.
I mean, as an alcohol connoisseur, are you bothered by people that don't fully understand but just enjoy, or is it just let people have their own?
We're all here for the beer.
That's fair. All right, stop, look back, tap jump on the way down a little faster. Yep. And then you got to tap A a little quicker. So it's B tap and then A tap.
Really?
If you get sick of this, I can intervene at some point, but it's totally up to you.
Yeah, it's up to you.
You'll get an asterisk next to your name. So
Yeah, asterisk is all fine with me at this stage.
He's right there. Get away. All right. So here's what you got to do. You got to jump. And on the way down, you have to shoot a rocket. A little late.
Oh, I was not able to shoot rocket. Oh, look at this.
All right, I'm going to get you to the next phase.
There's a next phase.
Yep, there you go. So there's
all right.
So this one's going to be bullets instead of rockets. And so you're going to hold down A, but you can't shoot them while you're at the top of the screen. You have to maybe walk that way.
Yeah.
And get to the center of the screen and shoot bullets back at the vertebrae, and that'll blow them up. Here for the beer could be the tagline for the channel, but might detract from the main event. So when I emailed Lance and I'm like, what do you want to drink? And he's like, I'm part of the Tallahassee Whiskey. What was the name of it?
Tallahassee Whiskey Society, yeah.
Whiskey Society. I'm like, we're in for a good night. Because he has strong opinions on whiskey, and he's probably going to bring his own. And all of those wishes came to fulfillment. So in this case, you have to shoot him with bullets instead of rockets. So you have to hold A instead of the explosion. You're going to hold the A button.
Okay.
Sorry, you're not sober enough to cope with this reality.
No, bam, 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 bam.
We have about.
I kept doing.
Yep, run away and hold A.
Yeah.
And so anyone that has questions, Lance is happy to answer them in the next 5 minutes of him fighting the skeleton boss for the first time. So instead of tapping A, hold A. So if you see those things that make that sound, hold A, it'll just be bullets. But if you guys have questions, throw them in chat right now. If you have someone we should raid, also we were excited to hear about that.
Well,
There's a few people on. Hornologist is on. That's a person that fixes watches on stream, which is pretty fun. Sid Hersey is an electronics person. Cooking Without Looking is someone that's blind that cooks food on stream. Texas Space Agency is a metallurgist who does metallurgy on stream. So yeah, if you guys have suggestions beyond that, feel free to throw them in chat. We will happy to entertain those. If not, ask your question for Lance Cooley, who's an expert in Superconducting materials. He's
Yeah,
happy
you
to
got it
answer any
right.
questions. I had to think about it, which is bad. 3 hours in and 5 drinks later and 370 milliliters of whiskey down the tube. Oh, there you go. You got 2 of them. Okay. You got two of the 6. So you need a couple more vertebrae. Walk away a good distance. And then turn back, shoot again. Harder or easier than Overwatch 2? Oh, there's another one. Good job.
Oh, it doesn't do it while I'm near him.
No, it doesn't. There's a very weird hitbox math on this. It depends on your x-axis. And you can't do it at the top. You have to like move down a little bit because you don't hit him at the top because Nintendo was weird when they generated this. But like you turn back and shoot at the core, you'll get some vertebrae. Should I have given you a heads up on this game?
No.
Would it made a difference? No. The best part is Olivia is watching this right now. She's going to judge you accordingly. She's like, Dad, I did this and I speed ran it in 10 minutes and 30 seconds. So.
Oh my God.
All right. We got a question by Tomcat. What is your take on continuing the pursuit of new materials for superconductivity? It seems more and more attention is on the material science that seems to hold promise in the next generation of superconductors. I mean, what's your perspective on like theory to lead us that way versus just like trial and error materials development?
So we've got an interesting discussion like the materials genome.
Oh, there it is. Okay, go right. Find the door.
So can we identify classes of materials and research them enough to give us a basis for prediction of properties like we might predict life from a genome? Okay. And I got the card. Yeah, there we go.
So go right. Civil forfeiture level. Steal money.
I don't need money.
You don't need money. You need to get to the end.
Yeah. And there's guidance from these fundamental discussions, right, about where to look. But honestly, pretty much every superconductor has been discovered by serendipity, maybe guided serendipity, but, hey, oh, look at that, 301887, that's pretty long.
You're fine.
Right, but
you're not the slowest, you're not the fastest, you're somewhere in between.
Yeah.
All right, serendipity.
Yeah, I think even with all the different tools, serendipity still rules.
Which is crazy, right? I mean, it's like somebody predicts something and something slightly related might be good, but it might not be good at all. I mean, all right, head on to end. You've had your initials in the system.
Yeah.
So how do you feel about like these high throughput machine automated synthesis of new materials? I mean, is that the answer? How we get something, breathtaking?
Maybe. I mean, it's going to turn up interesting things, but you still got to go back and measure it. You got to have reliable measurements. You got to take that and extrapolate to, things that are real. You got to make it into things that are useful, right? So materials libraries, I'm not so enthusiastic about it.
That's fair. All right, ladies and gentlemen, that's it. Lance, congratulations. You won the war on drugs by beating NARC. We had a couple hours in NARC Overwatch 2, which is a lot of fun. Thank you all for joining us. It's been it's been a pleasure. I've learned a lot. It's been a lot of fun. We didn't get through nearly as many of the predictions as we should have. I apologize, Lance, but thank you all for joining us. If anyone has any suggestions on who we should raid, throw them in chat. But again, Lance, it's been a pleasure. Do you have any parting words for the audience?
Ken, thank you very much. It's been fun. It's been amazing. Science is all about new experiences, new pathways. I really want to come back. This is a great time. It is a lot of fun.
We'll be happy to have you. And Olivia, thank you for serving as the support for Lance's
keeping me alive
gameplay. No, absolutely, because make no mistake, it is a challenge to talk science while playing video games at the same time, while being like 5 drinks of scotch or 5 drinks of whiskey in, 375 milliliters. We beat the bottle of 50-day old aged. and so, yeah, it's been a pleasure. Thank you for playing Overwatch as well as NARC and flattering us on playing through NARC for the first time ever. But thank you all for attending. Your questions are amazing. It's really what drives the stream forward. So thank you. In 2 weeks, our next guest will be Angela Knapp, who's an oceanographer, which is fun because she studies phytoplankton and the nitrogen cycle in the ocean, which is really fun. And so her answer for the biggest mistake she's ever seen or biggest accident is a shark attack. Oh, so how do you compete with that? But yeah. Angela Knapp will be back for in 2 weeks. So join us Wednesday. What does that end up being? It'll be April 26th. But until then, it's always a pleasure. Thank you for sticking by. We're gonna find out somebody educational related streaming to raid. But until then, it's always a pleasure. We'll see you next time.